if we get any kind of message of intelligent life, then I'm going to suggest our scientists try to make contact with it.
An unidentified object was recently discovered within our solar system, capturing the attention of astronomers worldwide. In October, telescopes stationed on Mount AA observed this mysterious entity, marking the first time an interstellar object has journeyed through our solar neighborhood, a historic milestone for astronomy and space science. NASA has addressed one of the most enigmatic objects to ever traverse our solar system, Oumuamua. Detected initially in 2017, this peculiar visitor left astronomers perplexed due to its unconventional characteristics and behavior. As the inaugural interstellar object known to fly through our solar system, Oumuamua has sparked countless theories regarding its origin, composition, and possible purpose. NASA's recent decision to declassify and discuss new images of this enigmatic object has reignited interest both within the space community and among the general public. These fresh insights are offering new data that could help unlock the object's secrets and are sparking new questions about the cosmos. Before we delve deeper, please remember to like and subscribe to our channel for more updates. The journey of Oumuamua through our solar system began in October 2017 when astronomers using the Pan-STARRS 1 telescope in Hawaii spotted an object moving along an unusual trajectory. Initially thought to be a comet, it lacked the characteristic tail that typically accompanies such celestial bodies. It was then classified as an asteroid, but its elongated shape and extraordinary speed challenged this categorization as well. Unlike anything previously observed, Oumuamua's sudden appearance and rapid departure left scientists scrambling for explanations. The name Oumuamua, meaning scout or messenger in Hawaiian, adds to the intrigue surrounding this visitor from another star system. NASA's choice to release new declassified images of Oumuamua not only acknowledges the object's mysterious nature, but also reflects the agency's commitment to transparency and the advancement of scientific knowledge. The newly unveiled images provide a more detailed look at Oumuamua, confounding old theories while offering new data that could help unravel its mysteries. What sets Oumuamua apart, even among the vast array of observed space objects, is its sheer peculiarity. Its elongated cigar-like shape, unusual velocity, and non-gravitational acceleration, meaning it appeared to speed up without any obvious reason, challenge everything previously understood about similar objects. One of the most captivating aspects of these new declassified images is their level of detail. NASA utilized its most advanced imaging technologies to capture Oumuamua from multiple angles, offering fresh perspectives that reveal the object's peculiar structure. Earlier images provided only a vague sense of its shape and size, but the new data presents a more nuanced view of its surface and composition. The images suggest that Oumuamua has a highly reflective surface, indicating it could be coated in metal or ice. This observation has led to speculation about its origins. Could it be a fragment of a larger object, debris from a distant star system, or something even more exotic? The declassified images also enhance our understanding of Oumuamua's motion. One of the most perplexing features of this object is how it accelerated as it exited the solar system. Typically, comets and asteroids follow predictable gravitational paths influenced by the sun and other planets. However, Oumuamua exhibited a slight acceleration away from the sun, sparking debates about the cause. The new images shed light on its trajectory, potentially helping scientists determine whether this acceleration was due to outgassing, a process where trapped gas within an object is released, or something entirely different. This sudden increase in speed could be attributed to various phenomena, but none have been conclusively proven. Outgassing has been a leading theory, but the absence of a visible gas trail complicates the picture. Usually, when comets approach the sun, they emit gas and dust, creating the familiar tails we associate with them. However, no such tail was observed around Oumuamua. This has led some researchers to propose that it could be composed of more exotic materials that behave differently when exposed to sunlight. The newly released images are crucial in helping scientists explore these possibilities further. Beyond insights into its structure and motion, the new images also raise questions about Oumuamua's origin. Where did it come from? How long had it been traveling through interstellar space before entering our solar system? Some theories suggest that Oumuamua could have originated from a distant star system, possibly ejected during the formation of a planet or star. The images indicate that the object has likely been traveling through space for millions of years, its surface weathered by cosmic rays and other forces. This would make Oumuamua a sort of time capsule, carrying information about regions of space far beyond our current reach. Another fascinating implication of NASA's declassified images is the possibility that Oumuamua could be an artificial object. While most scientists urge caution before jumping to conclusions, the object's unusual shape, speed, and behavior have led some to speculate that it might not be a natural object at all. Could it be a probe or spacecraft sent by an advanced civilization? Although this theory is highly controversial, the new images provide tantalizing clues that are difficult to dismiss outright. The object's highly reflective surface, anomalous acceleration, and absence of typical signs of outgassing all point to the possibility that Oumuamua could be more than just a rock or ice shard drifting through space. The implications are enormous. If Oumuamua is indeed an artificial object, it would represent the first direct evidence of extraterrestrial technology, profoundly impacting our understanding of life in the universe. It would suggest that we are not alone and that other civilizations are capable of interstellar travel. Even if Oumuamua turns out to be a natural object, its unusual behavior suggests phenomena in the universe that we do not yet fully understand. Either way, Oumuamua is forcing scientists to rethink many assumptions about the nature of space and the objects within it. NASA's release of these declassified images is also significant due to the technology used to capture them. The images were taken using some of the most advanced telescopes and space observation equipment available, showcasing the incredible progress made in space exploration technology. This new level of detail opens up exciting possibilities for future observations of interstellar objects. As our technology improves, we may be able to detect and study more of these objects as they pass through our solar system, providing valuable insights into the universe's nature and the formation of planets and stars. The implications of Oumuamua's visit and the new images extend beyond science. The discovery of an interstellar object has captured the public's imagination, inspiring books, films, and countless discussions about what lies beyond our solar system. The idea that an object from another star system could pass so close to Earth has sparked interest in space exploration and the search for extraterrestrial life. NASA's decision to release these images will likely fuel further interest, encouraging a new generation of scientists and enthusiasts to explore the universe's mysteries. Studying Oumuamua also has practical implications for future space exploration. As we develop technology to send spacecraft beyond our solar system, understanding objects like Oumuamua could provide valuable lessons about what we might encounter on interstellar missions. The declassified images offer a glimpse into the challenges future explorers might face, from navigating unfamiliar objects to dealing with unknown materials. By studying Oumuamua, scientists can gain insights to guide future missions, whether exploring distant star systems or traveling to the outer edges of our own solar system. While NASA's new images of Oumuamua answer some questions, they also raise many more. The object's unusual characteristics and behavior continue to baffle scientists, making it clear that we are only beginning to understand its full significance. As more data is analyzed and new theories develop, Oumuamua will undoubtedly remain a subject of intense study and debate for years to come. Whether it is a natural object or something more extraordinary, Oumuamua has already left an indelible mark on space exploration history, challenging our understanding of the universe and inspiring new ways of thinking about the cosmos. One of the most intriguing aspects of Oumuamua's visit is what it reveals about the possibility of life beyond Earth. Although the object shows no signs of life, its interstellar origins suggest that objects from other star systems could carry life's building blocks. Some scientists believe interstellar objects like Oumuamua could play a role in spreading life throughout the universe, acting as carriers for microbial life or organic molecules. The new images provide a closer look at Oumuamua's surface, which could hold clues about its composition and the potential for life elsewhere in the cosmos. The declassified images have reignited speculation, not only in the scientific community, but also among the public, especially those intrigued by extraterrestrial life. Despite NASA's emphasis on rigorous scientific inquiry and caution against premature conclusions. Oumuamua's unique nature continues to fuel interest in possibilities beyond conventional explanations. The high-definition images offer an unprecedented view of the interstellar visitor and fresh opportunities to engage with unconventional theories surrounding it. One provocative idea stemming from Oumuamua's observation is that its bizarre features may indicate artificial origins. This theory gained traction after the image release, primarily due to the object's shape, unusual acceleration, and failure to fit neatly into established celestial categories. Speculation about Oumuamua being a potential spacecraft or probe sent by an advanced civilization, while sensational, has been bolstered by its curious behavior. NASA and leading scientists note that such theories are speculative, but have not entirely dismissed them. What was once considered outlandish is now being studied more seriously, especially as the new images suggest even stranger features than initially detected. The images also highlight several surface features not previously visible. Some parts of Oumuamua appear smooth and reflective, while others are jagged and irregular. This contrast has led to new theories about its formation and composition. One possibility is that Oumuamua is a fragment of a larger object torn apart by gravitational forces, possibly during a close encounter with a star. Another suggests it might be composed of multiple materials, some more resistant to cosmic radiation and space weathering, resulting in its contrasting appearance. These surface variations could also indicate the presence of metals, ice, or organic compounds, which have important implications for understanding the processes that shaped it. In addition to its physical characteristics, Oumuamua's unexpected acceleration remains a major focus. The new images allow for a more detailed analysis of its movement through the solar system. Theories about why it accelerated range from mundane possibilities like outgassing to extraordinary ones like solar radiation, pressure acting on an artificially thin structure similar to a light sail. Although no conclusive evidence supports these theories, the precision of the new images provides more data for scientists to work with. Complicating matters is the lack of visible outgassing. Typically, comets exhibit tails as they approach the sun, resulting from sublimated ice transforming into gas. However, Oumuamua showed no such activity, making the outgassing hypothesis problematic. Researchers haven't ruled it out entirely. One possibility is that outgassing occurred in a direction not easily observed from Earth, or the gases involved are different and harder to detect. These alternative hypotheses are being re-examined with the new images as scientists search for clues about Oumuamua's acceleration. Another intriguing aspect is the timing of Oumuamua's appearance. Its close pass by Earth and detection by our instruments leads some to speculate about the improbability of such an event. Interstellar objects like Oumuamua are thought to be extremely rare, and our detection capabilities have been limited until recently. This raises questions about how often such objects pass unnoticed. Some scientists believe Oumuamua may not be as unique as it seems, suggesting many similar objects may have gone undetected. The new images provide valuable data to refine search strategies for similar objects, enabling astronomers to identify them more accurately. The scientific significance of Oumuamua also extends to planetary defense. Although it posed no threat during its flyby, its sudden appearance raises important questions about our ability to detect and track potentially hazardous objects from outside the solar system. The declassified images offer a clearer understanding of how Oumuamua approached the solar system, its speed, and its gravitational interactions. This information could be crucial in developing future systems for monitoring and potentially deflecting objects that pose a risk to Earth. If an object like Oumuamua were on a collision course, we might not have sufficient time to respond. Understanding such objects' behavior is essential for future preparedness. The release of these images marks a milestone in international collaboration in space exploration. The discovery and observation of Oumuamua involved astronomers and researchers worldwide, all contributing to data gathering and analysis. This level of cooperation is critical for tackling the mysteries posed by interstellar objects, as no single country or agency has the resources or expertise to handle all aspects of such complex events. The new images, processed using cutting-edge technology from several countries, demonstrate how global collaboration can lead to significant advancements in understanding the universe. Continued international partnerships will be essential for studying similar objects and making new space discoveries. Oumuamua's legacy will likely inspire a new era of research into interstellar objects. The declassified images remind us of how much we still don't know, especially about objects traveling between star systems. Oumuamua's unexpected visit has prompted astronomers to rethink models and consider new possibilities for what might be out there. The images, with their striking detail, set the stage for future studies that could help us understand not only Oumuamua, but also the broader context of interstellar space. The release also underscores the importance of continual technological advancement in space exploration. As telescopes, imaging devices, and computational techniques improve, so does our ability to study objects like Oumuamua in greater detail. The images were captured using a combination of optical, infrared, and radio observations, revealing features impossible to detect a decade ago. This highlights the need for ongoing investment in space observation technology, as each advancement brings us closer to unlocking the universe's secrets. Oumuamua may be the first interstellar object we've observed, but it likely won't be the last. Future telescopes will be better equipped to detect and study such objects in even greater detail. Despite the excitement, much work remains before we fully understand what Oumuamua is and where it came from. The declassified images provide a wealth of new information, but also raise new questions. Scientists are still debating whether its unusual shape results from natural processes or could be an artifact of technological origin. Its strange acceleration remains puzzling, and researchers are exploring possible explanations. The images are invaluable, but only the beginning of what promises to be a long and complex investigation into Oumuamua's true nature. The new images offer a tantalizing glimpse into the future of space exploration. As we push the boundaries of understanding, objects like Oumuamua remind us that the universe is full of surprises. Learning about interstellar objects reveals how much there is yet to discover. Oumuamua's visit was rare and unexpected, but has opened the door to a new field of study that could fundamentally alter our understanding of the universe. Each discovery brings us closer to answering profound questions about reality and our place in the cosmos. The story of Oumuamua continues to unfold as more details emerge, and the scientific community delves deeper into the unprecedented event of an interstellar object entering our solar system. The release of declassified images has put Oumuamua back in the spotlight, raising the stakes for scientific inquiry and opening new avenues for research and discovery. The latest developments, paired with high-resolution images, offer fresh opportunities for exploration, not only of the object itself, but also of the broader cosmic phenomena it represents. Oumuamua's impact on the scientific world cannot be overstated. It marks the first confirmed instance of an interstellar object traveling through our solar system, sparking interest in the broader universe beyond our immediate cosmic neighborhood. Before Oumuamua, most studies focused on objects originating within the solar system, such as asteroids, comets, and planets. Oumuamua's journey shifted that focus, pushing scientists to consider the wider galactic environment and unknown objects traversing space between stars. The new images provide a clearer picture of what to look for when identifying potential interstellar visitors. With the right technology and focused efforts, astronomers may soon detect more objects like Oumuamua, offering insights into processes occurring far beyond our solar system. Studying interstellar objects like Oumuamua has profound implications, especially in cosmology and astrophysics. Analyzing its composition, trajectory, and behavior can provide valuable insights into conditions in other parts of the galaxy. Interstellar objects are believed to be fragments of larger celestial bodies, planets, moons, or stars, ejected from their home systems through gravitational interactions or stellar explosions. Oumuamua offers a rare chance to study materials from beyond our solar system, potentially reshaping our understanding of star formation, planetary dynamics, and galaxy evolution. Oumuamua's presence has also prompted discussions about Panspermia, the theory that life can spread between planets or star systems via comets or asteroids. If interstellar objects can carry organic molecules or microbial life, they could play a crucial role in disseminating life throughout the universe. The new images, showing unusual surface features in detail, have led some researchers to speculate that it may contain organic compounds or water ice, essential for life as we know it. This would support the idea that life could be transported across vast cosmic distances. Recent discoveries of organic molecules in space bolster the Panspermia hypothesis. Complex organic molecules have been detected in exoplanet atmospheres and cometary ice. If Oumuamua contains similar compounds, it could link these discoveries to the broader possibility of life elsewhere. Even if it doesn't carry life, its journey through interstellar space raises questions about the environments it passed through and potential life-supporting conditions elsewhere. Oumuamua's strange behavior, especially its unexpected acceleration, has sparked further inquiry into forces acting on interstellar objects. One theory is that solar radiation pressure, force exerted by photons from the sun, caused its speed increase. However, this doesn't fully account for the observed acceleration. The declassified images provide detailed data on Oumuamua's shape and surface, offering clues about its interaction with solar radiation and other forces. This could help refine models of interstellar object movement. Another possibility is that Oumuamua's motion results from its physical structure. Some suggest it may be extremely lightweight and thin, resembling a large sheet or disk rather than a solid object. This could explain its acceleration without visible outgassing, as a thin structure is more sensitive to radiation pressure. The new images offer a clearer view of its dimensions, but leave room for interpretation of its composition and structure. If composed of lightweight or exotic materials, it could revolutionize our understanding of object formation and evolution in interstellar space. The images also provide data that could inform future missions to study interstellar objects. Observing objects like Oumuamua is challenging due to their speed and distance. By the time it was detected, Oumuamua was already exiting the solar system, making direct observation difficult. The new images help scientists anticipate what to expect when tracking similar objects. With this information, agencies like NASA and ESA could develop strategies for detecting and studying interstellar objects, possibly sending spacecraft to intercept and analyze them in real time. One concept is a fast flyby mission, launching a spacecraft toward an incoming interstellar object upon detection. This would allow scientists to gather detailed data before it leaves the solar system. Oumuamua's images provide a reference for such a mission's goals. Observing surface features and physical characteristics helps design instruments for interstellar exploration. While challenging and expensive, the scientific payoff could be immense, offering unique insights into distant galaxy regions. There's also growing interest in propulsion technologies enabling travel to other star systems. Initiatives like Breakthrough Starshot aim to send small probes to nearby stars using laser-driven sails. If Oumuamua-like objects are common, future missions might explore them and trace their origins. The images provide data to inform such missions, helping understand potential interstellar environments. The discovery has also refocused efforts on the search for extraterrestrial intelligence, SETI. While Oumuamua is likely natural, its unusual features prompt consideration of artificial origins. This leads to discussions on detecting signs of intelligent life on passing objects. The images detailing its surface and structure provide a basis for future studies on identifying artificial constructions. Distinguishing between natural and artificial objects is key in the search for extraterrestrial life. Oumuamua's characteristics, elongated shape, lack of a tail, unexplained acceleration, make it a prime candidate. The images help scientists develop criteria for identifying potential alien artifacts, such as geometric shapes or inconsistent behavior. While likely natural, studying Oumuamua refines the search for extraterrestrial technology in future encounters. If you enjoyed this video, please like and subscribe to our channel. Leave your comments below and tell us what you think the declassified images of Oumuamua reveal. We want to hear from you. Thank you for watching, and we'll see you next time.
Scientists were skeptical that we would ever be able to find these exoplanets because the stars that they orbit are so much brighter than the planets themselves.
An exoplanet is any planet located within our solar system, and some of these planets are free-floating, known as rogue planets. These wanderers move around the galactic center, while others orbit one or even two host stars. Astronomers first discovered exoplanets in the 1990s, and since then, thousands have been found. Now you can take a glimpse at them too. Spoiler alert, some exoplanets are extremely bizarre, while others closely resemble Earth and might even support life. The closest exoplanet to Earth is Proxima Centauri b, situated just 4.2 light-years away. Recently, astronomers have discovered that this world may be more similar to Earth than previously thought. It's only about 77% larger in mass compared to our home planet. It orbits a star that is dimmer and less massive than the Sun. Proxima Centauri b lies in the middle of its star's habitable zone, meaning liquid water and potentially life might exist there. It appears that the exoplanet is tidally locked with its parent star, so one side always faces the star, while the other remains in perpetual darkness. Scientists are still uncertain whether the planet has an atmosphere. It orbits very close to its star, completing one orbit every 11 Earth days. The star's radiation might be stripping away the planet's atmosphere. If so, Proxima Centauri b may not have liquid water on its surface. Another intriguing exoplanet is Gliese 832c, located 16 light-years away from Earth, a mere stone's throw in cosmic terms. This planet is 5 times as massive as Earth and orbits much closer to its parent star, resulting in a year that lasts only 36 days. However, since its star is a red dwarf, much cooler and dimmer than the Sun, Gliese 832c receives a similar amount of light and heat as Earth does. It's still unclear if Gliese 832c is truly Earth-like. It likely has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon happens when a planet absorbs more heat from its star than it can release back into space, making Gliese 832c more akin to the scorching Venus than our relatively cool Earth. TOI 700d is another Earth-like planet located 100 light-years away in the constellation Dorado. It orbits a small, cool dwarf star that's about 40% the mass and size of the Sun, with a surface temperature half that of our star. TOI 700d is the outermost planet in its system and is nearly the same size as Earth. It resides in its star's habitable zone, and no flares from TOI 700 reach it, increasing its potential habitability. This means it could possibly develop and sustain life. Scientists aren't sure about the exact conditions on its surface, but one computer simulation suggests it's an ocean-covered planet with a dense, carbon dioxide-dominated atmosphere, similar to what young Mars might have had. Another 3D model portrays TOI 700d as an all-land cloudless world, resembling what Earth might look like without oceans. Winds on TOI 700 days move from the night side to the area directly facing the star. In the Virgo constellation, there's an exoplanet that stands out due to its stunning magenta color, Gliese 504b. This world is located at a distance from its parent star that is several times the distance between the Sun and Jupiter. Having formed relatively recently, it still glows with heat, giving its surface a pinkish hue. Just 20 light-years from the Sun, which is relatively close in space terms, a bizarre rogue planet roams our Milky Way galaxy. Despite not orbiting any star, it possesses an incredibly powerful magnetic field, 4 million times stronger than Earth's. This exoplanet also produces amazing auroras. When it was discovered in 2016, astronomers initially thought it was a brown dwarf, too large to be a planet, but too small to be a star. Later, they confirmed it wasn't massive enough to be a brown dwarf. This mammoth planet is 1.2 times wider than Jupiter, the largest planet in our solar system, and over 12 times as massive. Astronomers believe its exceptionally strong magnetic field helps produce its auroras, which are generated differently than those on Earth. It might be that the planet's moon assists in creating these spectacular light shows. Travel 20,000 light-years from Earth, and you'd approach a red dwarf in the Sagittarius constellation. These stars are cool and small. Far from this cold star lies a planet so distant that it receives minimal heat, making it one of the coldest planets ever detected. The average surface temperature is below negative 360 degrees Fahrenheit, covering the entire planet with a thick layer of ice. Standing on its surface, you'd see only glaciers, plains, and mountains of ice. Yet astronomers suggest life might exist deep beneath the frozen exterior because the planet's core could generate enough heat to melt some of the inner ice. This could create a vast subsurface ocean, potentially teeming with unusual life forms. One of the oldest known exoplanets is PSR B 1620-26b, estimated to be about 12.7 billion years old, nearly 3 times the age of Earth, which is 4.5 billion years old. This means the so-called Genesis planet formed just about a billion years after the Big Bang. It's so ancient that its two parent stars have evolved into a white dwarf and a pulsar, the latter making nearly 100 revolutions per second. Sunrises on this planet must be truly awe-inspiring. The next exoplanet is unlike any other you've seen, often called Super Saturn or Saturn on steroids. Known as J1407b, it boasts a colossal ring system that's 640 times larger than Saturn's. Located 434 light-years from Earth, it's the only planet we know with rings similar to Saturn's, but on a much grander scale. If J1407b replaced Saturn in our solar system, its rings would appear many times larger than a full moon from Earth. Astronomers have observed a gap halfway through its rings, suggesting that an exomoon the size of Mars might orbit within this gap. Living on this moon would offer an incredible view every time you looked up at the sky. WASP-12b is an exoplanet that absorbs almost all the light from its star, making it one of the darkest worlds known. It's a giant planet, twice the size of Jupiter, and traps over 94% of the starlight that reaches its atmosphere. This likely contributes to its extreme surface temperatures, which can soar up to 4,600 degrees Fahrenheit, almost half as hot as the sun's surface. WASP-12b orbits so close to its host star that it completes an orbit in just one Earth day. Its night side is cooler, but still scorching at 2,200 degrees Fahrenheit. The temperature difference causes water vapor and clouds to form above the planet's surface. Occasionally, material from its superheated atmosphere spills onto its star. About 4,000 light-years from Earth, there's an exoplanet that might be a gigantic diamond. It's 5 times the size of Earth, but takes only 2 hours and 10 minutes to orbit its parent star, a pulsar rotating at 10,000 times per minute. This planet is denser than any other discovered, consisting mostly of carbon so dense that astronomers believe it could be crystalline. If true, parts of the planet could essentially be diamond. On WASP-76b, it rains iron on the night side, and daytime temperatures soar to 4,300 degrees Fahrenheit, hot enough to vaporize most metals. This exoplanet is slightly smaller than Jupiter and is located 640 light-years from Earth. Its extreme weather is due to its unusual orbit. It's 10 times closer to its star than Mercury is to the Sun. Consequently, the planet and star are tidally locked, so one side of WASP-76b always faces the star, while the other remains in darkness. There's a bright blue exoplanet about 62 light-years away that's slightly larger than Jupiter. Though it appears calm and its blue color reminds us of Earth, this planet is anything but peaceful. The hue comes from silicate atoms and particles in its atmosphere. Wind speeds can reach up to 5,400 miles per hour, several times the speed of sound. Temperatures can rise to 3,100 degrees Fahrenheit. Worst of all, it rains glass sideways, making it an inhospitable place for a vacation. Here's a quick space riddle. Why is the search for life in the universe like a tree? Because we're always looking for a place to plant it. Okay, moving on. Water is essential for life anywhere in the universe, so planets that could support life must have liquid water. Numerous factors need to align for this to happen. The planet must be in its star's habitable zone, where temperatures and atmospheric pressure allow simple life forms to evolve. If a planet is too close to its star, water evaporates, preventing oceans and seas from forming, much like Venus, which is similar in size and mass to Earth, but too close to the Sun for life. If it's too far, the planet becomes too cold, and water exists only as ice on the surface, possibly with liquid water deep below, as is the case with Neptune. Additionally, the planet must be solid with an atmosphere that shields it from solar radiation and supports breathing organisms. In our galaxy alone, there are countless stars, literally uncountable. Each may host planets, known as exoplanets, some of which might be in the habitable zone with conditions ripe for life. Out of 4,500 known exoplanets, scientists have identified 24 that could be superhabitable. These planets might be even more suitable for life than Earth. Such planets would be twice as massive and 1.3 times larger than Earth. A bigger size means stronger gravity and a denser, warmer atmosphere, promoting greater biodiversity. The host star should ideally be smaller than the Sun, with a lifespan of 15 to 30 billion years. compared to the Sun's under 10 billion years. This extended lifespan allows more time for life to develop. Scientists suggest focusing on dwarf stars, which are smaller, less luminous, and can live between 20 and 70 billion years. Superhabitable planets would have different climatic conditions. The average temperature should be about 8 degrees Fahrenheit, higher than Earth's, with more water in the form of clouds, liquid, and humidity, conditions that favor biodiversity. Such a planet would resemble Earth's tropical forests, but on a global scale. All 24 candidates for better than Earth are over 100 light-years away. With new generations of telescopes, we may soon determine if life exists there and if the conditions are suitable for humans. Now let's explore some potentially habitable exoplanets. Teegarden B orbits a red dwarf star about 12 light-years away. Red dwarfs can emit flares that strip away planetary atmospheres. But this host star is calm. Teegarden B has almost the same mass as Earth and completes an orbit in about 5 days, meaning a year there is less than a week on Earth. The furthest potential habitable planet is Kepler 1638b, located about 3,000 light-years away in the constellation Cygnus. It's classified as a super-Earth, twice as wide and 4 times as heavy as our planet. Gravity there would feel much stronger, making even a simple jump challenging. However, if life exists there, it's adapted to these conditions. LHS 1140b is a very rocky and solid planet. Although only 40% larger than Earth, it's 7 times more massive, resulting in a gravity of 3.25 Gs. For context, during an airplane takeoff, you experience about 1.5 Gs. Standing up would be tough there. Its large mass gives it a thicker atmosphere, and due to the greenhouse effect, temperatures can exceed 19 degrees Fahrenheit. It orbits its star quickly, completing a full circle in just 24 days. In the constellation Aquarius, there's an ultra-cold dwarf star named TRAPPIST-1. A small planet in its habitable zone is 3 times lighter than Earth. Its temperature is similar to ours, but gravity is half as strong, which would make movement easier. Kepler 452b resides in a system resembling an older version of ours. Its host star is 11% older than the Sun and nearly 2 billion years older. The exoplanet itself is 6.5 billion years old. However, it's extremely far away. Traveling at the speed of the New Horizons spacecraft, it would take about 26 million years to reach it, so pack a big lunch. The closest exoplanet to us is Proxima Centauri b, orbiting the red dwarf Proxima Centauri, the nearest star to the Sun. It's just 4.2 light-years away. Similar in size and mass to Earth, it likely has an icy structure like Neptune. Despite being our closest stellar neighbor, Proxima Centauri is too dim to see without a telescope. All these planets, including the 24 newly identified ones, are in their stars' habitable zones. In theory, we could colonize them in the future. However, the major hurdle is distance. Even the nearest exoplanet is too far with current technology. Modern rockets travel at 5 times the speed of sound, but it would take over 100,000 years to reach Proxima Centauri. We need faster methods to reach these new homes. Perhaps scientists have an answer. Warp drive technology. This concept involves manipulating space and time to create a bubble where normal motion laws don't apply, allowing a spacecraft to exceed the speed of light. While it sounds like science fiction, humanity has theorized such technology, known as the Alcubierre warp drive. Since objects with mass can't reach light speed conventionally, the spacecraft would compress space in front and expand it behind, moving space-time itself. The maximum speed could be 10 times the speed of light. However, warping space-time requires an enormous ship and energy equivalent to what Jupiter generates. Recent calculations by NASA's Jet Propulsion Laboratory suggest the ring creating the warp field doesn't need to be perfectly round. It can be donut-shaped, simplifying design and construction. This could make it possible to test on a spacecraft the size of Voyager 1. While it still seems like a distant dream, scientists are optimistic. NASA plans to launch its first interstellar mission in 2069 to explore potentially habitable planets outside our solar system. There are also theories about achieving light speed with laser technology or using nuclear energy and matter-antimatter collisions, though these remain speculative. For now, we continue to explore and stay tuned for future developments. People often describe planets as massive, freezing, boiling hot, or seismically active. Rarely do we think of them as shiny, but there's a world called LTT 9779b that might be the shiniest planet we've ever seen. This exoplanet is ultra-hot and acts like a giant space mirror because it's enveloped in a thick layer of reflective metallic clouds. Located about 264 light-years away, the most astonishing feature of this unusual world is that it reflects approximately 80% of all the light its parent star emits toward it. In comparison, Earth reflects only about 30% of the sunlight it receives. This bizarre exoplanet is even more reflective than Venus, the shiniest planet in our solar system, which reflects around 75% of sunlight due to its dense clouds. LTT 9779b is 5 times the size of Earth, making it the largest space mirror ever discovered. This planet was found by NASA's Transiting Exoplanet Survey satellite mission in 2020. Its highly reflective nature was uncovered later thanks to a follow-up investigation by the European Space Agency's exoplanet hunting spacecraft, EOPS, in a characterizing exoplanet satellite. Imagine a planet the size of Neptune but extremely hot, floating close to its star. If you stood on its surface and looked up, you'd see heavy clouds of metals overhead, raining down titanium droplets. The planet's size and extreme temperatures classify it as an ultra-hot Neptune. A planet's high reflectivity is known as albedo, and in the case of this shiny world, it's albedo puzzles scientists. Typically, planets that aren't icy or don't have thick, reflective clouds like Venus have low albedos because their atmospheres or surfaces absorb most of the starlight. Researchers initially believed LTT 9779b would have a low albedo, especially with surface temperatures reaching 3,650 degrees Fahrenheit on the side permanently facing its star. It was thought too hot for any kind of clouds to form, even metal or glass ones. Astronomers expected its atmosphere to be destroyed by the star, leaving a barren, rocky world, so discovering metallic clouds was a surprise. Researchers were eager to understand how these clouds formed. They compared it to how condensation appears in a bathroom after a hot shower. You can either cool the air until water vapor condenses or keep adding steam until the air becomes saturated. They concluded that the planet's atmosphere became oversaturated with silicate, leading metals to vaporize due to the intense heat on the day side. But the reflective nature isn't the only unusual feature of LTT 9779b. It's also an example of an extremely rare type called an ultra-hot Neptune. Astronomers have searched for such planets for decades. Its survival so close to its star might be linked to its high reflectivity. The metal clouds likely reflect light, preventing overheating and atmospheric evaporation. A heavy metallic atmosphere is also harder to strip away. About 850 light-years from Earth, a planet called WASP 121b orbits its star. This hot Jupiter is a gas giant extremely close to its star, resulting in average daytime temperatures around 5,000 degrees Fahrenheit. Like LTT 9779b, it has metallic clouds. WASP 121b has a bizarre oblong shape due to being tidally locked with its star. One side always faces the star, while the other remains in darkness, causing extreme temperature differences. This may contribute to the formation of metallic clouds. The water cycle on WASP 121b is bizarre. On the day side, intense heat breaks water molecules into atoms, which are then blown to the night side by winds reaching 11,000 miles per hour. There, cooler temperatures allow atoms to recombine into water molecules. The night side is cold enough for metal clouds of iron and corundum to form. When these clouds drift back to the day side, they vaporize, causing metal to rain down. Astronomers predict that WASP 121b may tear itself apart in several million years due to its fast winds and extreme temperatures. The star's gravity also stretches the planet, causing gases like iron and magnesium to leak from its atmosphere. The gravitational pull is so strong that the planet is on the verge of tidal disruption, which could eventually tear it apart completely. Just 20 light-years from the Sun, a bizarre rogue planet wanders the Milky Way. It has an incredibly powerful magnetic field, 4 million times stronger than Earth's. This exoplanet also produces stunning auroras. Initially thought to be a brown dwarf in 2016, it was later found to be too small for that classification. Nonetheless, it's a giant among planets, being 1.2 times wider than Jupiter and over 12 times as massive. Its strong magnetic field likely contributes to its auroras, which are generated differently from those on Earth, possibly with the help of a moon. Another planet you wouldn't want to visit is WASP 76b. On its night side, it rains iron, and daytime temperatures reach up to 4,300 degrees Fahrenheit, hot enough to vaporize metals. Slightly larger than Jupiter, it's located 640 light-years away. Its terrifying weather is due to its extremely close orbit to its star, 10 times closer than Mercury is to the Sun. The planet and star are tidally locked, so one side always faces the star while the other is in eternal darkness. In conclusion, the universe is filled with astonishing and diverse exoplanets. From Earth-like worlds that might harbor life to extreme planets with metallic rains and scorching temperatures, these distant planets challenge our understanding and spark our imagination about what lies beyond our solar system. The night sky is poised for a dramatic change as Antares, a red supergiant 700 times larger than our Sun, nears the end of its life. On the verge of a supernova, its explosion could outshine even Betelgeuse and rival the brightness of our entire galaxy. As we await this cosmic event, one question remains. What will happen when this stellar giant finally erupts?
So imagine looking on the horizon and sunrise is half the sky. Okay, that would be terrifying.
Is a supernova, first of all?
A supernova is an exploding star.
They are among the biggest explosions of radio energy in the entire universe.
Betelgeuse or Betelgeuse. It's a red giant star. If you put it where the sun is, it would extend out to the orbit of Jupiter. It's enormous. It's very unstable. It's about to explode.
Observable supernovae within our galaxy are exceedingly rare. The last recorded instance occurred centuries ago, making the potential explosion of Antares a once-in-a-lifetime spectacle. This impending celestial display offers astronomers and space enthusiasts a unique opportunity to witness cosmic history unfold before their eyes. As we embark on this journey through the cosmos, we'll explore the far-reaching impacts of this stellar explosion. From the creation of heavy elements to the potential formation of neutron stars or black holes, the aftermath of Antares supernova will shape the fabric of our galaxy for eons to come. Join us as we unravel the mysteries surrounding this cosmic ticking time bomb and its profound implications for our understanding of the universe. Antares, the red giant's final act. In the vast expanse of our night sky, one star stands out as a true celestial giant. Antares, a red supergiant located approximately 604 light-years from Earth, is a cosmic behemoth that captures the imagination of astronomers and stargazers alike. This stellar titan boasts a diameter roughly 700 times that of our Sun, making it one of the largest known stars in the universe. To put its size into perspective, if Antares were placed at the center of our solar system, its surface would extend beyond the orbit of Mars. This colossal star is not only enormous, but also incredibly bright, ranking among the top 20 brightest stars visible from Earth. Its prominent position in the constellation of Scorpius makes it a familiar sight to many observers of the night sky. Antares' impressive luminosity, however, is not constant. The star's brightness fluctuates, with its apparent magnitude varying between 0.88 and 1.16. These variations, while subtle to the naked eye, are a testament to the dynamic nature of this stellar giant. As Antares pulsates and shifts, it provides astronomers with valuable data about the life cycles of massive stars. But what makes Antares truly fascinating is its current stage of life. This red supergiant is nearing the end of its stellar journey, having exhausted its primary fuel source of hydrogen. In the core of Antares, a complex dance of nuclear fusion is taking place. The star is now fusing progressively heavier elements, a process that will ultimately lead to its dramatic demise. This final act in Antares' life is a precursor to one of the most spectacular events in the universe, a supernova explosion. As the star continues to fuse heavier elements, it's building up to a cosmic crescendo that will outshine entire galaxies. When Antares finally explodes, it's expected to become so bright that it could rival the combined luminosity of every other star in the Milky Way galaxy. Imagine looking up at the night sky and seeing a single point of light as bright as our entire galaxy. This is the potential future that awaits us when Antares goes supernova. The explosion will be visible even in broad daylight, turning night into day for a brief period. It's an event that would be remembered for generations, much like the supernovae recorded by ancient astronomers centuries ago. The impending explosion of Antares offers a unique opportunity for scientific study. By observing this nearby supernova, astronomers hope to gain unprecedented insights into the death throes of massive stars. The data collected from this event could revolutionize our understanding of stellar evolution and the processes that create the heavy elements essential for life in the universe. Interestingly, the name Antares itself holds a clue to the star's appearance and historical significance. Derived from ancient Greek, the name means anti-Ares, or rival of Mars. This moniker was given because the star's reddish hue bears a striking resemblance to the red planet. Ancient astronomers noted this similarity, leading to Antares being sometimes referred to as the heart of the Scorpion in its host constellation. The connection between Antares and Mars goes beyond mere appearance. It speaks to the human tendency to find patterns and relationships in the night sky, a practice that has been central to navigation, timekeeping, and mythology for thousands of years. This celestial rivalry between Antares and Mars has been recognized by various ancient civilizations, each incorporating the star into their own cosmic narratives. The anatomy of a supernova. As we venture deeper into the mysteries of stellar evolution, we encounter one of the most awe-inspiring phenomena in the universe, the supernova. This cosmic spectacle represents the grand finale of a massive star's life, a celestial fireworks display that outshines entire galaxies. But what exactly is a supernova, and why does it captivate astronomers and casual stargazers alike? A supernova is, in essence, the largest observable explosion from Earth. It occurs when a star, having exhausted its nuclear fuel, can no longer support its own weight. The resulting collapse triggers a catastrophic explosion that releases an enormous amount of energy and light. This cosmic cataclysm is so bright that it can be seen across vast distances, sometimes even visible to the naked eye during daylight hours. The sheer scale of a supernova explosion is difficult to comprehend. During this cosmic event, material is expelled at incredible speeds, reaching several percent of the speed of light. To put this into perspective, imagine a mass several times that of our sun being ejected into space at velocities approaching 30 million miles per hour. This violent expulsion of stellar material creates shockwaves that ripple through the surrounding interstellar medium, shaping the cosmic landscape for light years around. But the supernova's influence extends far beyond its immediate vicinity. These stellar explosions play a crucial role in the cosmic ecosystem, acting as factories for heavy elements. The intense heat and pressure during a supernova create conditions that forge elements heavier than iron, which are then scattered throughout space. This process enriches the interstellar medium with the building blocks necessary for the formation of new stars, planets, and even life itself. The aftermath of a supernova is equally fascinating. Depending on the initial mass of the star, the explosion can result in one of two exotic outcomes: a neutron star or a black hole. Neutron stars are incredibly dense objects where the mass of a sun is compressed into a sphere roughly the size of a city. Their gravity is so intense that a teaspoon of neutron star material would weigh billions of tons on Earth. Black holes, on the other hand, represent an even more extreme outcome. These cosmic enigmas are regions of space where gravity is so strong that nothing, not even light, can escape. They continue to be a source of fascination for scientists and the public alike, challenging our understanding of the fundamental laws of physics. The frequency of supernovae in our galaxy adds another layer of intrigue to these cosmic events. It's estimated that between 2 to 12 stars go supernova in the Milky Way each century. Yet despite this relatively high occurrence rate, No supernova has been observed in our galaxy for several centuries. This statistical anomaly suggests that we are overdue for such an event, heightening the anticipation among astronomers for the next galactic supernova. The last recorded supernova in our galaxy was observed by Johannes Kepler in 1604, more than 4 centuries ago. Known as Kepler's supernova, it was visible to the naked eye for over a year, rivaling the brightness of the planet Mars. The long gap since this last observed event underscores the rarity of visible supernovae in our cosmic neighborhood and highlights the potential significance of Antares' eventual explosion. A celestial companion, Antares B. While Antares steals the spotlight in our cosmic narrative, it's not a solitary player in this stellar drama. Hidden in plain sight is Antares B, a lesser-known companion star that adds another layer of intrigue to this celestial system. Described as a little spark of glittering emerald, Antares B is a bluish-white star that orbits its giant red counterpart. The relationship between Antares and Antares B forms what astronomers call a binary star system. These cosmic partnerships are more common than one might think, with many stars in our galaxy existing in pairs or even larger groups. The dance between these stellar companions can have profound effects on their evolution and ultimate fate. In binary systems like Antares, the gravitational interaction between the stars can significantly influence their life cycles. This cosmic tango can alter the rate at which stars age, affect their mass loss, and even determine the nature of their eventual demise. The presence of Antares B adds an extra variable to the equation when considering the future supernova of Antares. The study of binary star systems provides astronomers with valuable insights into stellar evolution. By observing how these paired stars interact over time, scientists can refine their models of stellar life cycles and better predict the outcomes of various stellar scenarios. This knowledge is crucial for understanding not only individual stars, but also the broader cosmic processes that shape our universe. One particularly intriguing example of a binary system on the brink of a stellar explosion is T Corona Borealis. This system consists of a red giant star and a white dwarf, locked in a cosmic embrace that's about to reach a dramatic climax. Astronomers predict that T Corona Borealis will experience a nova explosion between now and September 2024, offering a rare opportunity to witness a stellar outburst in real time. A nova, while less powerful than a supernova, is still a spectacular cosmic event. In the case of T Corona Borealis, the anticipated nova is expected to be visible to the naked eye, potentially rivaling the brightness of Polaris, the North Star. This means that for a brief period, observers on Earth will be able to see what appears to be a new star blazing in the night sky. The last recorded eruption of T Corona Borealis occurred in 1946, making the upcoming event a significant astronomical occurrence. Observers can expect to see this temporary new star with the naked eye for at least a couple of days, and it will remain visible through binoculars for about a week. This provides a unique window for both professional astronomers and amateur stargazers to study and appreciate the dynamic nature of our universe. The rapid nature of nova events adds to their allure. As one researcher notes, this new star will reach its peak brightness within 24 hours of the nova explosion. This sudden burst of light serves as a stark reminder of the ever-changing nature of our cosmos, where stellar dramas unfold on timescales both impossibly long and surprisingly short. While the T Corona Borealis nova and the potential Antares supernova are different in scale, they both highlight the dynamic and sometimes explosive nature of binary star systems. These cosmic partnerships can lead to some of the most energetic events in the universe, shaping the very fabric of space around them. The cosmic ecosystem, life after supernova. In the wake of a supernova, the universe enters a phase of cosmic renewal. These stellar explosions are not merely destructive events, but rather catalysts for creation on a grand scale. Supernovae play a pivotal role in the cosmic ecosystem, acting as celestial factories that forge and distribute heavy elements throughout the universe. The process begins in the final moments of a massive star's life. As the star exhausts its nuclear fuel, it undergoes a catastrophic collapse followed by an explosive rebirth. This violent event creates conditions of extreme heat and pressure, enabling the formation of elements heavier than iron. These elements, such as gold, silver, and uranium, cannot be produced through the normal fusion processes that occur during a star's lifetime. In the midst of this cosmic crucible, these newly formed heavy elements are violently expelled into space. The explosion disperses material several times the mass of the Sun at incredible speeds, enriching the surrounding interstellar medium. This enriched material becomes the raw material for future generations of stars and planets. The elements produced in supernovae are essential for the formation of planets and life as we know it. Carbon, oxygen, and nitrogen, the building blocks of organic compounds, are among the elements scattered by these cosmic explosions. Iron, crucial for the formation of rocky planets like Earth, is also a product of supernovae. In a very real sense, we are all made of stardust, forged in the fires of ancient stellar explosions. This cosmic distribution of elements illustrates the interconnectedness of stellar and planetary evolution. The death of one star paves the way for the birth of new celestial bodies, creating a continuous cycle of cosmic renewal. It's a testament to the dynamic nature of our universe, where destruction and creation are intricately linked. Despite the crucial role supernovae play in cosmic evolution, predicting which stars will go supernova remains a significant challenge for scientists. The difficulty lies in determining the precise stages of fusion occurring within a star's core. Many stars, including red supergiants like Antares, may have millions of years left before they reach their explosive finale. The complexity of stellar evolution makes it challenging to pinpoint exactly when a star will exhaust its nuclear fuel. Factors such as mass, composition, and even interactions with companion stars can influence a star's lifespan and eventual fate. This uncertainty adds an element of cosmic suspense to the study of massive stars, as astronomers watch and wait for signs of impending stellar demise. However, the study of red supergiants like Antares provides valuable insights into the conditions that lead to supernova events. These massive stars are in a critical phase of stellar evolution, having exhausted their primary hydrogen fuel and now fusing heavier elements. By observing the behavior and characteristics of stars like Antares, astrophysicists can refine their models of stellar evolution and improve their ability to predict future supernovae. The data gathered from studying red supergiants helps scientists understand the internal processes that occur in the final stages of a massive star's life. This knowledge is crucial for developing more accurate models of stellar evolution and supernova mechanisms. As one astrophysicist noted, supernovae are indeed fascinating phenomena like no other, and they serve as a reminder of the dynamic processes that govern the universe. Each observation of a red supergiant like Antares adds to our understanding of these cosmic giants. The variations in brightness, temperature, and spectral characteristics provide clues about the internal furnaces of these stars. This information, combined with theoretical models, allows scientists to piece together the puzzle of stellar evolution and supernova prediction. The study of supernovae and their progenitor stars has far-reaching implications beyond astronomy. It touches on fundamental questions about the origin of elements, the formation of planets, and the conditions necessary for life to emerge in the universe. By understanding these cosmic processes, we gain insight into our own origins and place in the vast cosmic tapestry. Witnessing cosmic history. The universe unfolds its secrets to us in rare and spectacular events, and few are as awe-inspiring as a supernova in our own galaxy. These cosmic explosions, marking the dramatic end of a star's life, are not just visually stunning, but also scientifically invaluable. Yet, despite their significance, observing a supernova in the Milky Way is an exceptionally rare occurrence. Consider this: the last recorded supernova in our galaxy was observed over 4 centuries ago. In 1604, Johannes Kepler documented a stellar explosion that was visible to the naked eye for more than a year. This event, known as Kepler's supernova, rivaled the brightness of Mars at its peak. Since then, our galaxy has been notably quiet, at least from our earthly vantage point. The scarcity of observable supernovae in our cosmic neighborhood makes the potential explosion of Antares all the more significant. If this red supergiant were to go supernova in our lifetime, It would offer an unprecedented opportunity for scientific study and public engagement with astronomy. However, the apparent lack of supernovae in our galaxy doesn't mean these cosmic events are not occurring. Modern technology has revolutionized our ability to detect and study supernovae, even if they're not visible to the naked eye. Advanced telescopes and sophisticated detection methods allow astronomers to observe supernovae in distant galaxies, expanding our understanding of these cosmic phenomena. These technological advancements have opened new avenues for research. Astronomers can now study supernovae across vast cosmic distances, comparing data from multiple events to refine our models of stellar evolution and explosion mechanisms. This wealth of information helps scientists piece together the complex puzzle of how stars live and die. The potential future observation of Antares supernova would be a game changer in this field. Being relatively close to Earth at about 604 light-years away, Antares offers a unique opportunity for detailed study. Its explosion would provide unprecedented data on the death throes of a massive star, allowing scientists to test and refine their theories in real time. Imagine the wealth of information that could be gathered from such an event. Astronomers would be able to track the supernova's evolution from its earliest stages, observing changes in brightness, temperature, and composition as the explosion unfolds. This data would be invaluable for understanding the physical processes that drive stellar explosions and the formation of neutron stars or black holes. Moreover, the explosion of Antares would offer insights into the production and distribution of heavy elements in the universe. Supernovae are cosmic forges, creating elements heavier than iron and scattering them across space. By studying Antares supernova, scientists could gain a better understanding of how these elements are formed and dispersed, shedding light on the chemical evolution of our galaxy. The public impact of such an event would be equally significant. A supernova visible to the naked eye would capture global attention, potentially inspiring a new generation of astronomers and space enthusiasts. It would provide a rare opportunity for people worldwide to witness cosmic history firsthand, fostering a deeper appreciation for the dynamic nature of our universe. However, it's important to note that predicting when Antares will go supernova remains challenging. While the star is in the later stages of its life, it could still have thousands or even millions of years left before it explodes. This uncertainty underscores the need for continued observation and study of Antares and other potential supernova candidates. In the meantime, astronomers continue to refine their methods for detecting and studying supernova across the cosmos. Each observation, whether of a distant galaxy or a nearby star, adds to our understanding of these cosmic events and their role in shaping the universe. A new chapter in cosmic understanding. The study of Antares and supernovae opens a new chapter in our cosmic understanding. These stellar explosions not only distribute heavy elements crucial for planet formation, but also provide insights into the life cycles of massive stars. As astrophysicists refine their models, each observation of red supergiants like Antares brings us closer to predicting future supernovae. This ongoing research enhances our comprehension of the universe's dynamics and our place within it. The potential explosion of Antares represents a pivotal moment in astronomy. It offers a rare opportunity to witness cosmic history and advance our knowledge of stellar evolution. As we continue to explore the night sky, we're reminded of our deep connection to the stars. The cosmic drama unfolding above us is not just a distant spectacle, but a fundamental part of our own story. In the words of one astronomer, supernovae serve as a reminder of the dynamic processes that govern the universe.
From the outside, you can't tell what is inside a black hole.
What if everything you know about the universe is inside out? Recent theories suggest our entire cosmos could be nestled within a black hole. This mind-bending concept challenges our understanding of space and time, proposing that the very fabric of our reality might be contained within what we once thought was a cosmic destroyer.
So your feet approach the black hole faster than your head does.
Okay.
You snap into two segments. Then each of those two segments, eventually they snap into two segments. You go from 1 to 2 to 4 to 8 to 16, and you're the stream of particles descending down
now,
to the abyss.
Are you feeling pain or are you not?
And
fact, if you want to see a black hole tonight, go outside, look in the direction of Sagittarius. That's where we have the center of the galaxy, and a black hole weighing perhaps 2 to 4 million times the mass of the Sun, lurking right at the center of our own backyard.
Black holes, those mysterious cosmic entities, have long been a source of fascination for scientists and stargazers alike. These gravitational behemoths, known for their insatiable appetite for matter and light, might hold secrets beyond our wildest imaginations. But what if they're more than just cosmic vacuum cleaners? What if our entire universe exists within one? This audacious theory raises a central question. Could our entire universe be inside a black hole? It's a concept that turns our perception of reality on its head, challenging everything we thought we knew about the cosmos. As we embark on this journey of cosmic exploration, prepare for revelations that will stretch the limits of your imagination and redefine our place in the universe. Black holes, cosmic destroyers or creators. Black holes have long been viewed as the ultimate cosmic destroyers, voracious entities that consume everything in their path. This perception stems from their most defining characteristic, a gravitational pull so intense that nothing, not even light, can escape once it crosses the event horizon. But what if these cosmic giants are more than just nature's perfect vacuum cleaners? To understand the potential creative role of black holes, we must first explore their formation and nature. Black holes are born when massive stars collapse under their own gravity at the end of their lives. As the star's core implodes, it becomes incredibly dense, creating a gravitational field so strong that it warps the very fabric of space-time around it. This results in the formation of an event horizon, the point of no return beyond which nothing can escape the black hole's grasp. The immense gravitational pull of black holes is a testament to their power. Imagine a force so strong that it can bend light itself, creating a cosmic funhouse mirror effect around its edges. This gravitational lensing, as it's called, is one of the ways astronomers detect and study these elusive cosmic entities. But black holes aren't just found in isolation. In fact, they play a central role in the structure of our universe. At the heart of nearly every galaxy, including our own Milky Way, lies a supermassive black hole. These cosmic behemoths can have masses millions to billions of times that of our Sun, exerting a gravitational influence that shapes the very galaxies they inhabit. The presence of these supermassive black holes at galactic centers has led scientists to question their role in cosmic evolution. Are they merely the end result of galactic formation, or do they play an active part in shaping the universe we see today? This question challenges the traditional view of black holes as purely destructive forces. While it's true that their gravitational pull is immense, black holes are surprisingly inefficient at capturing matter from large distances. They only consume objects that venture very close to their event horizons. This selective appetite suggests that black holes might have a more nuanced role in cosmic processes than previously thought. In fact, black holes can be sources of incredible energy and cosmic phenomena. When material falls towards a black hole, it forms a swirling disk of gas and dust called an accretion disk. As this material heats up to millions of degrees, it releases enormous amounts of energy in the form of radiation. This process can create some of the brightest objects in the universe, such as quasars and active galactic nuclei. These energetic processes associated with black holes hint at their potential creative power. The radiation and jets emitted by active black holes can influence star formation and galactic evolution, shaping the cosmic landscape around them. In this light, black holes begin to look less like cosmic destroyers and more like cosmic architects, playing a crucial role in the ongoing story of our universe. The idea that black holes might be creators rather than just destroyers opens up fascinating possibilities. Could these cosmic entities be more than just the endpoint of stellar evolution? Might they, in fact, be the birthplaces of new universes? This concept challenges our understanding of the cosmos and raises intriguing questions about the nature of reality itself. If black holes can create new universes, could our own universe be nested within a larger black hole? And if so, What implications does this have for our understanding of space, time, and the fundamental laws of physics? The universe within, a new perspective. The idea that our entire universe could be nestled within a black hole is a concept that challenges our fundamental understanding of reality. This theory proposes that the cosmos we observe and inhabit might be contained within the event horizon of a massive black hole in a larger, parent universe. It's a perspective that requires us to reconsider our notions of space, time, and the very fabric of existence. To grasp this concept, imagine our universe as a bubble floating in a vast cosmic ocean. In this analogy, the surface of the bubble represents the event horizon of a black hole, and everything we know and experience exists within this bubble. The ocean surrounding it would be the larger universe or multiverse that contains our black hole universe. This theory stems from the similarities between the properties of our universe and those of black holes. Both exhibit extreme densities, intense gravitational effects, and mysterious singularities at their cores. The Big Bang, which marked the birth of our universe, shares characteristics with the formation of a black hole, suggesting a possible connection between these cosmic phenomena. One of the key principles supporting this theory is the concept of quantum gravity. This theoretical framework attempts to reconcile quantum mechanics with Einstein's theory of general relativity. In the realm of quantum gravity, the extreme conditions inside a black hole could potentially give rise to a new universe with its own set of physical laws and constants. The implications of this theory are profound. If true, it would mean that the laws of physics as we know them might only apply within our universe bubble. Beyond the event horizon of our cosmic black hole, entirely different rules could govern reality. This concept challenges our understanding of causality and the arrow of time, as events in the parent universe might influence our own in ways we cannot yet comprehend. To visualize this complex idea, consider a Russian nesting doll. Each doll represents a universe contained within a black hole of a larger universe. Our cosmos would be one of these dolls, with potentially infinite layers of reality both above and below us. This nested structure could explain the hierarchical nature of cosmic structures we observe, from subatomic particles to galactic superclusters. The black hole universe theory also offers potential explanations for some of the most perplexing mysteries in cosmology. For instance, it could account for the apparent flatness and uniformity of our universe, as the interior of a black hole would naturally create such conditions. It might also provide insights into the nature of dark energy, the mysterious force driving the accelerating expansion of the universe. Moreover, this concept aligns with the idea of cosmic inflation, the rapid expansion of the universe in its earliest moments. The intense gravitational forces at the event horizon of a black hole could produce an effect similar to cosmic inflation, explaining the uniform distribution of matter and energy we observe in our universe. However, it's crucial to note that this theory remains highly speculative. As one researcher points out, we do not understand how this central singularity works to properly understand the black hole center. This highlights the significant gaps in our knowledge regarding black holes and their implications for understanding the universe. Cosmic incubators, black holes as universe generators. As we venture deeper into the cosmic mysteries surrounding black holes, a revolutionary idea emerges. These enigmatic objects might not just be destroyers of matter, but creators of entire universes. This concept transforms our understanding of black holes from cosmic dead ends to cosmic incubators, potentially giving birth to new realms of existence. The notion of black holes as universe generators stems from the complex interplay between quantum mechanics and gravity. At the heart of this theory lies the concept of Hawking radiation, proposed by the renowned physicist Stephen Hawking. This phenomenon suggests that black holes aren't entirely black, but emit a faint glow of particles over time. Hawking radiation occurs due to quantum effects near the event horizon of a black hole. In this region, pairs of particles and antiparticles spontaneously pop into existence. Normally, these pairs would quickly annihilate each other. However, near a black hole's event horizon, one particle might fall into the black hole while the other escapes, appearing to be emitted by the black hole itself. This process has profound implications for our understanding of black holes and the universe at large. Over extremely long periods, Hawking radiation could cause black holes to slowly evaporate and shrink. This evaporation process might seem to contradict the idea of black holes as universe creators, but it's precisely this mechanism that opens up intriguing possibilities. As a black hole evaporates, it becomes smaller and denser. Some scientists propose that when a black hole reaches a critical size, the immense gravitational forces and quantum effects could trigger the formation of a new universe. This new cosmos would be born from the singularity at the center of the black hole, expanding into its own space-time separate from our own. In this scenario, black holes act as cosmic recycling machines. They consume matter and energy from one universe, only to use that material as the seeds for a new universe. This process creates a fascinating cycle of cosmic birth, death, and rebirth. The implications of this theory extend far beyond a single universe. If black holes can indeed generate new universes, it suggests the existence of a vast cosmic network. Our universe might be just one of countless others, each born from a black hole in a parent universe. This concept aligns with the idea of a multiverse, where an infinite number of universes exist simultaneously. Imagine a cosmic tree with each branch representing a universe and each leaf a black hole. These leaves might sprout new branches, creating an ever-expanding structure of interconnected realities. In this model, our universe could be a single branch on an infinitely complex cosmic tree. This theory also provides a potential explanation for the fine-tuning of our universe. The physical constants and laws that govern our cosmos seem perfectly balanced to allow for the existence of complex structures like galaxies, stars, and life. If our universe is one of many born from black holes, it's possible that each new universe inherits slightly different properties from its parent. Over time, this cosmic natural selection could result in universes increasingly capable of supporting complex structures. However, it's important to note that while these ideas are intellectually stimulating, they remain highly speculative. As one researcher points out, the surprising new insights show that there is still much to learn about black holes. Our current understanding of black holes, quantum mechanics, and the nature of the universe is still limited, and these theories push the boundaries of our knowledge. The concept of black holes as universe generators also raises fascinating philosophical questions. If our universe is indeed nested within a larger black hole, what does that mean for our understanding of reality? Are there layers of existence beyond our perception? Could the physical laws we observe be merely local phenomena with entirely different rules governing the larger multiverse? Living in a black hole, what it means for us. The idea that we might be living inside a black hole seems like something out of science fiction. Yet this theory has gained traction among some physicists, challenging our fundamental understanding of the cosmos. If true, it would revolutionize our perception of reality and our place within it. Living in a universe inside a black hole would have profound implications for our understanding of space and time. The laws of physics as we know them might only apply within our cosmic bubble, with entirely different rules governing the larger reality beyond our event horizon. This concept challenges our notions of causality and the arrow of time, suggesting that events in a parent universe could influence our own in ways we cannot yet comprehend. One of the most intriguing aspects of this theory is its potential to explain certain cosmic phenomena we observe. The apparent flatness and uniformity of our universe, for instance, could be a natural consequence of existing within a black hole. The intense gravitational forces at the event horizon could produce effects similar to cosmic inflation, accounting for the uniform distribution of matter and energy we see around us. Moreover, this theory might provide insights into the nature of dark energy, the mysterious force driving the accelerating expansion of our universe. If our cosmos is indeed nested within a black hole, the expansion we observe could be a result of our universe's growth within its host black hole. This perspective offers a fresh approach to one of the most perplexing mysteries in modern cosmology. The black hole universe theory also opens up fascinating possibilities regarding parallel universes and alternate dimensions. If our universe is one of many born from black holes, it suggests the existence of a vast cosmic network of interconnected realities. Each black hole in our universe could potentially be the birthplace of a new cosmos, creating an infinite fractal structure of nested universes. This concept aligns with the idea of a multiverse, where an infinite number of universes exist simultaneously. In this model, our universe might be just one branch on an infinitely complex cosmic tree, with each leaf representing a black hole capable of sprouting new universal realities. The implications of such a structure are mind-boggling, suggesting layers of existence beyond our current perception. However, it's crucial to acknowledge the limitations of our current understanding and technology. While these theories are intellectually stimulating, they remain highly speculative. Our knowledge of black holes, quantum mechanics, and the nature of the universe is still limited, and these concepts push the boundaries of our scientific understanding. As one researcher points out, we do not understand how this central singularity works to properly understand the black hole center. This statement underscores the significant gaps in our knowledge and the challenges we face in exploring these cosmic frontiers. Our current technology is far from being able to directly observe or test many aspects of these theories, leaving us in a realm of mathematical models and theoretical speculation. Despite these limitations, the idea of living in a universe inside a black hole offers exciting prospects for future research and exploration. It challenges us to think beyond our current paradigms and consider new possibilities for the nature of reality. This theory could potentially provide a unified framework for understanding various cosmic phenomena, from the Big Bang to the large-scale structure of the universe. If proven true, this concept would indeed revolutionize our place in the cosmos. It would suggest that our universe is part of a larger, perhaps infinite, cosmic structure. This perspective could fundamentally alter our understanding of creation, existence, and the very nature of reality itself. It raises profound philosophical questions about our significance in the grand cosmic scheme and the potential for other forms of life and civilizations existing in parallel universes. The horizon of discovery, what lies ahead? The journey to unravel the mysteries of black holes and their potential role as universe generators is far from over. Scientists are embarking on ambitious research projects and experiments to probe deeper into these cosmic enigmas. The quest to understand black holes and their implications for our universe remains one of the most exciting frontiers in modern physics. Current research focuses on several key areas. One primary goal is to detect and analyze gravitational waves produced by black hole mergers. These ripples in space-time offer valuable insights into the behavior and properties of black holes. Advanced detectors like LIGO, Laser Interferometer Gravitational Wave Observatory, and Virgo are at the forefront of this effort, capturing data from cosmic collisions billions of light years away. Another critical area of study involves observing the event horizons of black holes. The Event Horizon Telescope project, which captured the first ever image of a black hole in 2019, continues to push the boundaries of our observational capabilities. By combining data from multiple radio telescopes around the globe, scientists aim to create even sharper images of black holes and their surrounding environments. However, the path to proving or disproving the black hole universe theory is fraught with challenges. The very nature of black holes makes direct observation of their interiors impossible with current technology. The intense gravitational fields and extreme conditions near the event horizon pose significant obstacles to gathering data. Moreover, the scales involved in these theories are mind-boggling. If our universe is indeed nested within a larger black hole, the parent universe would exist on a scale far beyond our current observational limits. This raises fundamental questions about the nature of scientific inquiry and the limits of human knowledge. Despite these hurdles, scientists remain undaunted. They are developing new theoretical frameworks and mathematical models to bridge the gap between quantum mechanics and general relativity. These efforts aim to create a unified theory of quantum gravity, which could provide crucial insights into the behavior of black holes and the potential for universe generation. Technological advancements will play a crucial role in future explorations. More sensitive gravitational wave detectors, improved space-based telescopes, and in potentially even quantum computers could revolutionize our ability to study cosmic phenomena. These tools may allow us to probe deeper into the nature of black holes and test the predictions of various theoretical models. The implications of these discoveries extend far beyond the realm of physics. The concept of a black hole universe challenges our fundamental understanding of reality, space, and time. It raises profound philosophical questions about the nature of existence and our place in the cosmos. If our universe is indeed one of many nested within black holes, it suggests a vastness to reality that is difficult to comprehend. It opens up possibilities for parallel universes, alternate dimensions, and forms of existence beyond our current imagination. This perspective could reshape our understanding of creation, evolution, and the very fabric of reality. The ongoing exploration of black holes and their potential role as universe generators serves as a testament to human curiosity and ingenuity. It pushes the boundaries of our knowledge and technological capabilities, driving innovation across multiple scientific disciplines. As we continue to peer into the cosmic abyss, we are reminded of the endless possibilities that await discovery. The universe, it seems, is far more complex and mysterious than we ever imagined. Each new revelation opens up new questions, fueling the endless cycle of scientific inquiry and exploration. A universe of wonder. The black hole universe theory challenges our fundamental understanding of reality. It suggests our cosmos might be nestled within a larger black hole, part of an infinite cosmic structure. This concept offers potential explanations for mysteries like dark energy and cosmic inflation. It also raises profound questions about the nature of existence and our place in the grand scheme. While highly speculative, this theory encourages us to think beyond our current paradigms. It reminds us that the universe is far more complex and mysterious than we imagine. As we continue to explore these cosmic frontiers, we're pushed to question our assumptions and expand our understanding. Perhaps one day, as one researcher speculates, we will know exactly what lies inside of a black hole. Until then, we remain in awe of the vast, unknown cosmos that surrounds us.
Hope we go back to the moon soon. We should have a base on the moon, like a permanently occupied human base on the moon, and send people to Mars, and build a city on Mars. That's what we should do.
In a universe teeming with enigmas and unexplored frontiers, Elon Musk, the visionary entrepreneur and founder of SpaceX, has consistently pushed the limits of technology and exploration. But what if we told you he believes the moon harbors secrets beyond our wildest dreams? Does Elon Musk possess knowledge we're unaware of? And is there a larger scheme unfolding? Join us on a mind-expanding journey as we delve into Elon Musk's psyche and uncover the hidden truths about Earth's closest celestial neighbor. The allure of outer space's mysteries continues to captivate humanity's brightest minds. This is why numerous space agencies have intensified their exploration plans for the coming decade. Nations like the United States, China, and Russia are deeply involved in these ventures. Even private companies like Elon Musk's SpaceX have joined the race, leading to collaborations among them. Recently, a fascinating partnership emerged between Elon Musk and China. Following leaks from the Tesla and SpaceX CEO, a startling discovery made by China on the moon's far side was revealed. This finding raises questions about what China uncovered and why it was concealed. Could this be evidence of extraterrestrial life? The China National Space Administration has been making significant strides in space exploration, challenging NASA's dominance. China has even built its own space station, adding to its impressive accomplishments. During their lunar missions, China stumbled upon a remarkable discovery, a secret that Elon Musk later shared with the world. In response, the China National Space Administration and the China Atomic Energy Authority issued an official announcement addressing the leaked information and revealing the astonishing news globally. The announcement disclosed that Chinese scientists, during their lunar research, made a groundbreaking breakthrough. They unearthed the sixth new lunar material, named Shanjit. This extraordinary mineral was discovered by researchers at the Beijing Research Institute of Uranium Geology, while examining surface samples collected by China's Chang'e 5 robotic mission. To confirm its uniqueness, the material was certified by the International Mineralogical Association and its Commission on New Minerals, Nomenclature, and Classification. Musk noted that Shanjit, belonging to the lunar marilite category, holds special importance. It marks the first lunar material discovered and observed by Chinese scientists, placing China alongside the United States and Russia as the third nation to achieve such a significant find. The mineral sample, a single crystalline particle measuring just 10 microns in diameter, was meticulously separated from over 140,000 tiny particles. It then underwent thorough analysis using advanced mineralogical techniques. The mission that led to this incredible discovery was the Chang'e 5 robotic expedition. This groundbreaking journey was launched from the Wenchang Space Launch Center in South China's Hainan province. After an awe-inspiring voyage, it successfully landed on the moon, becoming the third spacecraft in the 21st century to do so, following China's Chang'e 3 and Chang'e 4. This space mission, lasting 23 days, proved to be one of China's most daring and challenging ventures into space. Its goal was to collect lunar rocks and soil, and it triumphantly returned with 1,731 grams, a monumental achievement. Remarkably, it had been 46 years since the last lunar materials were brought back from our celestial neighbor. The China National Space Administration oversaw the distribution of the first batch of lunar samples obtained by Chang'e 5. These samples, each weighing 17.5 grams, were carefully divided into 21 lots and provided to researchers from 13 domestic institutions. These esteemed scientists were working on an impressive array of 31 lunar-related scientific projects. This accomplishment etched China's name into the annals of history. Collaboration was crucial in this monumental endeavor, as experts from various departments, including the Chinese Academy of Sciences, Ministry of Education, and Ministry of Natural Resources, united to study the moon samples. Their research revealed that these tiny moon crystals are over 1 billion years old, with a width comparable to a human hair. Such a profound revelation deepens our understanding of the moon's geological history and composition, paving the way for further scientific exploration and discovery. The remarkable findings from the Chang'e 5 mission left scientists at the International Mineralogical Association astounded. Their analyses confirmed that the tiny moon crystal has a composition unlike anything previously seen. It is intricately linked to other minerals found exclusively on the moon or within meteorites. These significant milestones have not only enhanced our understanding of the moon's origin and evolution, but also laid the groundwork for exploring the effective use of lunar resources. However, this astonishing revelation wasn't the only surprise from the moon mission. Another groundbreaking discovery caught the attention of Musk, a prominent advocate for clean energy. Among the approximately 140,000 lunar particles examined from the Chang'e 5 moon rocks, scientists found traces of helium-3. This form of helium is rare on Earth, but is believed to be abundant on the moon. It has been envisioned as a potential fuel source capable of revolutionizing the production and use of clean and efficient energy on our planet. This sheds light on why Musk chose to leak this information to the public. For years, scientists have been fascinated by helium-3 and its potential as a fuel for nuclear fusion, a remarkable energy production process where 2 light atoms combine to form a heavier one under extreme heat and pressure. The prospect of harnessing helium-3 for nuclear fusion has sparked great interest. Its unique properties and abundance on the moon open possibilities for a future energy revolution. Musk's decision to share this information signifies its potential to transform our energy landscape, paving the way for cleaner, more sustainable, and efficient energy generation. While fusion naturally occurs in stars' cores, scientists have yet to develop a fusion reactor that produces more energy than it consumes. However, helium-3 emerges as a highly promising fuel source, producing significantly less radiation and nuclear waste than other elements. According to Musk, helium-3 does exist on Earth, but in limited quantities. In contrast, it's believed to be more abundant on the moon, where the solar wind has deposited it onto the lunar soil over billions of years. The European Space Agency highlights that despite the lack of viable reactors to use helium-3, a lunar resource race has already begun. Numerous spacefaring nations and private companies, including the United States and China, have shown keen interest in mining the moon for helium-3. The discovery of a new helium-3 deposit by Chang'e 5 could accelerate the global competition to exploit the moon's mineral resources. This revelation has undoubtedly pushed the boundaries of space exploration and resource utilization. Beyond his endeavors in clean energy, Musk has revealed plans to establish human settlements on the moon as part of his vision to expand human civilization beyond Earth. His ambitious plans align with the growing belief that the moon holds great potential for sustaining human life. Moreover, Chang'e 5's further exploration of the lunar surface led to the detection of water. This finding raises the exciting possibility of humanity surviving and thriving on the moon. The presence of water opens doors for sustaining future lunar missions and establishing long-term human presence, further stimulating scientific curiosity and exploration. For many years, scientists believed the moon to be a dry, waterless, celestial body. However, thanks to the Chinese lunar lander, a groundbreaking discovery was made: water on the moon's surface. This isn't mere speculation. Scientists have confirmed water's presence on the lunar terrain. During its mission, Chang'e 5 collected over 60 ounces of soil and rock samples, unveiling not only rare minerals, but also the remarkable finding of water. Before returning to Earth, Chang'e 5 used its onboard instruments to take crucial measurements. Even from 239,000 miles away, scientists deduced that the probe likely encountered water on the moon. Water, vital for human survival, isn't typically expected in deep space. Its scarcity poses a significant challenge for exploring the final frontier, necessitating extensive preparations. This new discovery could revolutionize our understanding of lunar resources. To delve deeper, scientists conducted further research to investigate whether the trace amounts of water found could be harnessed by astronauts during extended missions. A team led by scientists from the Institute of Geology and Geophysics at the Chinese Academy of Sciences analyzed the wealth of data collected by Chang'e 5, seeking to unlock the secrets of lunar water. The intriguing findings from the data analysis revealed signs of water indicated by the probe's readings. Scientists identified H2O molecules based on how they reflected or absorbed the sun's radiation, known as spectral reflectance. These results impressed Dr. Meg Siegler, a senior scientist at the Planetary Science Institute in Tucson, Arizona. Dr. Siegler suggested there might be more water on the moon than previously thought. These ongoing discoveries have reshaped scientists' understanding of lunar water. Contrary to initial assumptions after the Apollo astronauts returned in 1969, believing the moon was entirely dry, subsequent missions have challenged this notion. The Indian Space Research Organization's Chandrayaan-1 mission, for example, detected signs of hydration on the sunless lunar surface. However, it was difficult to determine whether it was H2O or its chemical relative, hydroxyl. Casey Hannibal, a NASA postdoctoral fellow, compared hydroxyl to a substance found in drain cleaners, adding to the discovery's intrigue. Further missions uncovered ice in hard-to-reach craters near the moon's poles. These perpetually shadowed craters provide conditions favorable for preserving ice. Such findings prompted scientists to revisit Apollo samples with renewed curiosity. During analysis, water molecules were detected within glass beads and minerals in the samples, bringing both excitement and confusion as it challenged the moon's perceived dryness. Some scientists were skeptical, questioning whether the water originated from the moon or was due to moisture contamination on Earth. However, subsequent evidence emerged. A month before the Chinese lander's discovery, NASA announced the existence of water in a sunlit region of the moon. Without landing on the lunar surface, NASA achieved this by sending a high-altitude aircraft called SOFIA up to 45,000 feet. From this vantage point, SOFIA used advanced infrared technology to observe specific wavelength signals emitted by water molecules. The telescope's findings suggested water might be widespread across the moon, not just at the poles as previously thought. The mystery deepened when China's Chang'e 5 mission made another intriguing discovery. Besides shedding light on unresolved phenomena, the rover U2 debunked certain mysteries, including the so-called mystery hut found on the moon in November 2021. Initially spotted from a distance, the small square object resembled a hut, sparking curiosity. Scientists sent the rover for a closer look. As U2 approached, it became clear it wasn't a man-made structure, but an ordinary moon rock. The rock, later named the Jade Rabbit due to its rabbit-like appearance, had created an illusion through light and shadow. Therefore, Musk, the visionary behind SpaceX, is tirelessly working toward his ambitious goals, including helping NASA return to the moon by 2025. However, China also harbors long-held aspirations to establish a lunar presence, not just to claim a moon base, but also to propel nuclear-powered rockets into space in the future. They believe this will pave the way for colonization and enhance exploration of the final frontier. China's efforts haven't gone unnoticed, as they plan to build their first moon base by 2028 and send astronauts there in subsequent years. The moon base will be a remarkable feat, powered by nuclear energy to meet its long-term power needs. Its design will include a lander, hopper, orbiter, and rover, all constructed through the Chang'e 6, 7, and 8 missions. Wu Weiren, the chief designer of China's lunar exploration program, confidently predicts that Chinese astronauts will set foot on the moon within a decade. Regarding the use of nuclear energy to power the base, he asserts it's the best option for meeting the station's energy requirements. China's accomplishments have put them in the global spotlight, from successful lunar probes to building their own space station and preparing for Mars exploration. Their ambitious plans position them as formidable competitors to NASA's dominance in space exploration. Meanwhile, NASA continues to make strides, with a rover on Mars and plans to send astronauts back to the moon within this decade. Both China and the United States are investing billions in lunar missions, not only to explore the moon and its resources, but also to advance space travel to Mars. China's focus is on constructing a moon base at the lunar South Pole, deemed most suitable for accessing water, an essential resource. They also envision expanding their base into an international research station. With this goal, China has set forth a roadmap for robotic lunar and deep space exploration. Upcoming missions will deploy landers, orbiters, and relay satellites, testing key technologies needed for constructing the International Lunar Research Station in the 2030s. Initially, the ILRs will serve as a robotic base, becoming permanently habitable after 2035. In the coming years, China is set to make significant strides in lunar exploration. Building on the success of the Chang'e 5 mission in 2020, Chang'e 6 is planned as a follow-up mission for 2026. It aims to retrieve up to 2 kilograms of material from the lunar far side's South Pole Aitken Basin. To overcome engineering challenges, the landing site will likely be near the same latitude as the Chang'e 4 mission's landing in the Von Karman crater. A new lunar relay satellite will be launched to ensure seamless communication, targeting the moon's South Pole vicinity. Around the same time, Chang'e 7 will launch, equipped with an orbiter, lander, rover, and a mini-flying detector. This comprehensive mission will study lunar topography, material composition, and the environment. The mini-flying detector will play a crucial role in identifying water ice, focusing on permanently shadowed areas in the lunar South Pole. These missions aim to unlock the secrets of the moon's unexplored regions. Looking further ahead, Chang'e 8 is projected to launch by 2028, serving as a testbed for in-situ resource utilization and 3D printing technologies. This mission signifies China's commitment to exploring the potential of utilizing lunar resources and advancing cutting-edge technologies. China is also preparing for a crewed lunar landing in 2030, planning to send 3 astronauts to the moon. This ambitious endeavor will involve 2 launches of a new generation crew launch vehicle. 2 astronauts will have the opportunity to set foot on the lunar surface for about 6 hours, conducting experiments and gathering valuable data. Both lunar landers and spacecraft for this mission are currently under development to support these extensive plans. The China International Lunar Research Station will be established in the early 2030s. The ILRS will see 5 launches dedicated to placing orbital and surface infrastructure for energy, communications, resource utilization, and other advanced technologies. These missions will require the lifting power of the Long March 9, a super heavy lift rocket. Excitingly, Chinese officials have announced they're redesigning the Long March 9 to make it reusable. While it's certain that Musk is involved in lunar projects, it's also clear that the Chinese Space Agency has a bright future ahead, with numerous discoveries and advancements on the horizon. As this journey into Elon Musk's enigmatic world and his discoveries about the moon continues, one thing is abundantly clear: the moon isn't what we thought it was. Musk's vision and relentless pursuit of knowledge have opened our minds to a universe of possibilities. Experts suggest that the moon's secrets might just be the beginning, and our universe remains full of awe-inspiring wonders that could shake the very foundations of our understanding of the cosmos. Einstein's theories of relativity have long been the cornerstone of our understanding of the universe, stating that nothing with mass can travel faster than light. But what if there's a way to bypass this cosmic speed limit? New research suggests that by warping space itself, we might be able to achieve the seemingly impossible, faster than light travel.
According to Einstein's special theory of relativity,
well, you need to take the very large and the very small together to understand the universe as a whole.
And these two tiny particles have just opened up a whole new chapter in our understanding of light, gravity, and the universe around us.
Faster than light, FTL travel has the potential to revolutionize our understanding of the universe and enable interstellar exploration. Once confined to the realm of science fiction, warp propulsion is now being taken seriously by scientists as a possible method for achieving FTL travel. This shift from fantasy to scientific consideration represents a significant leap in our approach to space exploration. The stakes are high when we consider the current limitations of space travel. Voyager 1, for instance, took 35 years just to exit our solar system. In contrast, FTL travel could open up the possibility of interstellar journeys, dramatically expanding the scope of human exploration. The implications of such technology for humanity's future in space are profound, potentially transforming our species from earthbound observers to true cosmic voyagers. Einstein's cosmic speed limit. As we contemplate our potential as cosmic voyagers, a fundamental question arises. What if the very laws of physics that seem to constrain us also hold the key to our liberation? Einstein's theories have long been considered unbreakable, but recent research suggests there might be a loophole that could redefine our understanding of space travel. At the heart of this cosmic conundrum lies Einstein's theory of relativity, which establishes a universal speed limit. This cosmic speed limit, approximately 300,000 kilometers per second, is the speed at which light travels through a vacuum. According to Einstein's equations, nothing with mass can reach, let alone exceed, this speed. The reason for this limitation is rooted in the relationship between mass and energy. As objects approach the speed of light, they gain mass, making it increasingly difficult to accelerate them further. This creates a seemingly insurmountable barrier, as it would require infinite energy to push an object with mass to light speed. This principle has far-reaching implications for space travel. Our current spacecraft, impressive as they are, fall far short of this cosmic speed limit. Even our fastest probes would take thousands of years to reach the nearest star systems. This stark reality has long been a source of frustration for scientists and space enthusiasts alike, seemingly confining humanity to our cosmic backyard. However, the story doesn't end there. In the realm of theoretical physics, a revolutionary concept is emerging that challenges our fundamental understanding of space-time itself. This new approach doesn't attempt to break Einstein's speed limit directly. Instead, it proposes a way to circumvent it entirely. The key lies in the manipulation of space-time fabric. Instead of accelerating a spacecraft to impossible speeds, this theory suggests we could warp the very space around it. Imagine a ship encased in a bubble of distorted space-time, where the fabric of space contracts in front of the vessel and expands behind it. In this scenario, the ship itself never exceeds the speed of light within its local space. Yet, from an outside perspective, it appears to move faster than light relative to distant objects. This concept, while still highly theoretical, opens up new avenues for exploration and understanding of the cosmos. It suggests that the limitations imposed by Einstein's theories may not be as absolute as previously thought. By thinking outside the conventional framework of propulsion and acceleration, we might achieve what was once considered impossible. The implications of such a breakthrough are profound. If realized, this technology could transform humanity's relationship with the universe. Interstellar travel, once the realm of science fiction, could become a reality. We could explore distant star systems, study alien worlds up close, and perhaps even establish colonies beyond our solar system. However, it's crucial to note that this concept remains firmly in the realm of theory. The the challenges in making it a reality are enormous, ranging from the fundamental physics involved to the practical engineering hurdles. The energy requirements alone are staggering, far beyond our current technological capabilities. The Alcubierre drive, folding space-time. In the face of these daunting challenges, scientists have turned their attention to manipulating the medium of space itself. What if, instead of pushing against the cosmic speed limit, we could bend the rules of reality? This radical approach might just hold the answer to faster-than-light travel. Enter the Alcubierre drive, a theoretical concept proposed by Mexican physicist Miguel Alcubierre in 1994. This groundbreaking idea offers a potential solution to the seemingly insurmountable barriers of interstellar travel. The Alcubierre drive operates on a principle that sounds more like science fiction than reality: warping space-time itself. The concept is deceptively simple, yet profoundly complex. Instead of attempting to accelerate a spacecraft to impossible speeds, the Alcubierre drive proposes to create a bubble of warped space-time around the vessel. This bubble would expand space behind the spacecraft and contract it in front, effectively moving the ship through space-time without the ship itself moving within its local space. Imagine a surfer riding a wave. The surfer doesn't swim through the water, but instead rides on top of the moving wave. Similarly, a spacecraft using the Alcubierre drive would ride a wave of warped spacetime, potentially achieving faster-than-light travel relative to distant objects. One of the most intriguing aspects of this theory is its implications for the passengers of such a spacecraft. Unlike conventional propulsion methods, which subject travelers to intense acceleration forces, the Alcubierre drive offers a surprisingly comfortable journey. Within the space-time bubble, occupants would experience no felt acceleration. This means no crushing g-forces or physical stress typically associated with high-speed travel. However, the Alcubierre drive is not without its challenges. The most significant hurdle is the enormous energy requirement needed to create and sustain the warp bubble. Current estimates suggest that the energy needed would be equivalent to the mass energy of Jupiter. This staggering amount of energy presents a major barrier to the practical implementation of the theory. Another crucial component of the Alcubierre drive theory is the concept of negative mass or negative energy density. This exotic form of matter is theorized to be necessary for creating the warp bubble. However, negative matter remains purely theoretical, as it has not been discovered or proven to exist in our universe. This complicates the feasibility of the technology, adding another layer of complexity to an already challenging concept. Despite these obstacles, the Alcubierre drive theory continues to captivate scientists and space enthusiasts alike. It represents a potential loophole in our understanding of physics, offering a tantalizing possibility of faster-than-light travel without violating the principles laid out by Einstein's theories of relativity. The implications of such a breakthrough are profound. If realized, this technology could transform our relationship with the cosmos. Interstellar exploration, once confined to the realm of science fiction, could become a tangible reality. We could study distant star systems up close, explore alien worlds, and perhaps even establish colonies beyond our solar system. Recent breakthroughs, bringing warp drive closer to reality. As scientists push the boundaries of possibility, a startling question emerges. What if the key to faster-than-light travel has been hiding in plain sight all along? Recent discoveries are challenging our understanding of physics and bringing us closer to unlocking the secrets of warp drive technology. Two researchers, Dr. Eric Lentz and Dr. Harold White, have made significant strides in this field, potentially revolutionizing our approach to interstellar travel. Dr. Eric Lentz has proposed a groundbreaking new approach to warp drive that utilizes existing physical properties and positive energy densities. This innovative method stands in contrast to traditional concepts that relied on negative matter, which has yet to be discovered or proven to exist. Lentz's study describes how acceleration to the speed of light could be achieved through the manipulation of warp bubbles, using only known positive energy densities for implementation. Meanwhile, Dr. Harold White, a former NASA specialist, has made an equally exciting discovery. White identified natural warp bubbles within a Casimir cavity, a finding that could serve as a model for creating larger warp drives. This discovery suggests that these structures could potentially be mimicked on a larger scale, bringing us closer to the realization of the first true warp drive. The advancements made by Lenz and White represent a significant leap forward in warp drive technology. Their work could potentially simplify the energy requirements for warp technology, moving us closer to practical applications. This is a marked improvement over previous concepts, such as the original Alcubierre drive, which required an energy equivalent to the mass of Jupiter, an amount far beyond our current technological capabilities. One of the most promising aspects of these new approaches is their use of known physical properties and positive energy densities. This eliminates the need for exotic, theoretical materials like negative matter, which has been a major stumbling block in previous warp drive concepts. By working within the realm of known physics, these new theories bring faster-than-light travel closer to the realm of possibility. The implications of these advancements are profound. If realized, this technology could transform our relationship with the cosmos. Interstellar exploration, once confined to the realm of science fiction, could become a tangible reality. We could study distant star systems up close, explore alien worlds, and perhaps even establish colonies beyond our solar system. However, it's important to note that significant challenges remain. While these new approaches show promise, they are still theoretical and require further research and development. The energy requirements, though potentially reduced, are still substantial. Engineering such a device would require technological capabilities far beyond our current level. Despite these challenges, the work of Lenz and White represents a significant step forward in our quest for faster-than-light travel. Their research has opened up new avenues of exploration and brought us closer to understanding how we might one day traverse the vast distances of space. Beyond speed, time travel, and philosophical implications. As we stand on the precipice of interstellar exploration, an even more mind-bending possibility emerges: the potential for time travel. Could our pursuit of warp drive technology inadvertently unlock the secrets of traversing not just space, but time itself? The implications of faster-than-light, FTL, travel extend far beyond the realm of space exploration, challenging our fundamental understanding of reality and causality. The concept of FTL travel opens doors to theoretical possibilities that were once confined to the realm of science fiction. By manipulating space-time for FTL travel, we may also be creating conditions that allow for movement through time. This interconnection between space and time is a cornerstone of Einstein's theories. And as we push the boundaries of one, we inevitably affect the other. Theoretical frameworks suggest that if we can warp space to achieve FTL, we might also manipulate time in ways that could lead to time travel scenarios. These scenarios wouldn't necessarily violate the laws of physics as we understand them, but they would require us to reconsider our notions of cause and effect. The very fabric of reality as we perceive it could be altered by such capabilities. The philosophical implications of potential time travel are profound and far-reaching. One of the most well-known paradoxes associated with time travel is the grandfather paradox. This thought experiment questions the consequences of altering past events, such as preventing one's own birth. Such scenarios challenge our understanding of causality and the nature of free will. Moreover, the ability to travel through time would fundamentally change our perception of existence itself. Our current understanding of life and death, of beginnings and endings, is deeply rooted in our linear experience of time. If we could move freely through time, these concepts would need to be radically redefined. The pursuit of FTL travel and its potential time-bending consequences invite us to reconsider our place in the universe. As we contemplate the possibility of traversing vast cosmic distances in the blink of an eye, we must also grapple with the idea that our actions could have consequences across different points in time. This realization could dramatically alter our decision-making processes and our sense of responsibility to future or past generations. Furthermore, the development of FTL and time travel technologies would likely have profound impacts on various fields of study. Historians could potentially observe past events firsthand, revolutionizing our understanding of history. Scientists could verify or disprove long-held theories by directly observing phenomena across vast stretches of time. The boundaries between different scientific disciplines might blur as the interconnectedness of space, time, and matter becomes more apparent. However, it's crucial to note that these possibilities remain firmly in the realm of theory. The practical challenges of achieving FTL travel, let alone time travel, are immense. The energy requirements alone are staggering, far beyond our current technological capabilities. Additionally, the potential paradoxes and ethical dilemmas posed by time travel would need to be carefully considered and addressed before any such technology could be implemented. Despite these challenges, the exploration of FTL travel and its implications continues to push the boundaries of science and philosophy. It encourages us to question our assumptions about the nature of reality and our place within it. As we delve deeper into these concepts, we are forced to confront fundamental questions about existence, causality, and the very fabric of the universe. The road ahead, challenges and possibilities. As we push the boundaries of our understanding, we must confront a sobering reality. The energy needed for FTL travel could be equivalent to the mass of Jupiter. This astronomical requirement raises a crucial question. Are we on the brink of a breakthrough, or have we reached the limits of what's physically possible? The pursuit of faster-than-light FTL travel faces significant challenges, primarily the enormous energy requirements to warp space-time effectively. Current research suggests that the energy needed could be equivalent to the mass of Jupiter, a staggering amount that far exceeds our present technological capabilities. This energy barrier represents one of the most formidable obstacles in the quest for interstellar travel. Despite these challenges, the scientific community continues to explore innovative approaches to FTL travel. Researchers are investigating various theoretical models and attempting to refine existing concepts to reduce energy requirements and increase feasibility. However, the practical application of warp drive technology remains a considerable challenge, requiring further research to establish its technical viability. The ongoing pursuit of FTL travel is not merely a technological endeavor. It has profound implications for space exploration, scientific discovery, and the future of human civilization. Successful FTL travel could redefine humanity's place in the universe, opening up possibilities for interstellar exploration and potentially transforming our species from earthbound observers to true cosmic voyagers. Current research efforts focus on several key areas. Scientists are exploring ways to manipulate space-time more efficiently, potentially reducing the energy requirements for creating warp bubbles. Additionally, researchers are investigating alternative propulsion methods that could achieve similar results with less energy input. These efforts continue to push the boundaries of our current scientific understanding, indicating that while significant challenges remain, the quest for FTL travel is advancing. However, skepticism about FTL travel theories persists, particularly regarding the existence of negative matter. Many theoretical models for warp drives require negative matter or negative energy density to function. As of now, negative matter remains undiscovered and largely speculative, adding another layer of complexity to the development of FTL technology. The potential impact of FTL capabilities on space exploration and scientific discovery cannot be overstated. If realized, this technology could allow humans to study distant star systems up close, explore alien worlds, and perhaps even establish colonies beyond our solar system. The scientific knowledge gained from such expeditions could revolutionize our understanding of the universe and our place within it. Moreover, the development of FTL technology could have far-reaching implications for human civilization. It could lead to the establishment of interstellar trade routes, the colonization of distant planets, and the spread of human culture across the cosmos. Such advancements could fundamentally alter our perspective on resources, territory, and the very nature of human existence. Yet it's crucial to approach these possibilities with a balanced perspective. While the potential benefits of FTL travel are immense, the challenges are equally significant. The energy requirements alone present a formidable barrier, not to mention the complex engineering challenges involved in creating a functional warp drive. Additionally, the potential risks and ethical considerations of such technology must be carefully evaluated before any practical implementation. Despite these obstacles, the pursuit of FTL travel continues to captivate scientists, engineers, and dreamers alike. It represents a testament to human ingenuity and our relentless drive to explore the unknown. Even if FTL travel remains out of reach for the foreseeable future, the research conducted in its pursuit is likely to yield valuable scientific insights and technological advancements. A new frontier of discovery. The pursuit of faster-than-light travel represents a transformative shift in our understanding of the universe. It challenges long-held beliefs and prompts us to reevaluate established scientific principles. As we explore the possibilities of FTL travel, we're not just pushing the boundaries of technology, but also expanding our philosophical frameworks. The potential success of FTL travel could lead to unprecedented advancements in human understanding and exploration. It opens up the possibility of studying distant star systems and alien worlds up close, potentially enabling humanity to become true cosmic voyagers. As we contemplate this future among the stars, it's crucial to recognize that the journey towards FTL travel is both a technical and philosophical challenge. It reshapes our understanding of reality itself. While significant obstacles remain, the ongoing pursuit of FTL travel continues to inspire scientific inquiry and fuel our collective imagination about humanity's place in the cosmos. Apollo 11's mission to the Moon on July 20th, 1969, was one of the most significant events in human history.
To achieving the goal, before this decade is out, of landing a man on the Moon and returning him safely to the Earth.
Astronauts Neil Armstrong and Buzz Aldrin became the first humans to set foot on the lunar surface.
It's one small step for man, one giant leap for mankind.
While Michael Collins orbited above in the command module. This achievement symbolized human ingenuity and determination. However, Buzz Aldrin has long intrigued the public with his comments about the Moon. Over the years, he has hinted that the Moon may not be exactly what we think, sparking curiosity and speculation about its mysteries. Aldrin's views on the Moon often venture into the unusual. The second man to walk on the lunar surface, Aldrin has openly discussed his experiences during the mission. While most see the Moon as a barren, lifeless satellite, Aldrin has implied there's more to it. His reflections range from personal experiences to broader thoughts on what the Moon might represent for humanity, challenging the conventional view of the Moon as a cold, rocky body and suggesting that its mysteries are far from fully uncovered. During the Apollo 11 mission, Aldrin and Armstrong conducted experiments and collected samples to bring back to Earth. However, Aldrin has hinted in interviews that their time on the Moon may have revealed phenomena not fully disclosed to the public. Though his comments are often vague, they suggest the Moon could harbor unknown phenomena, leaving room for speculation and imagination about what was truly observed during the first lunar landing. Aldrin often emphasizes the sense of awe and mystery he felt on the Moon, describing it as an otherworldly place. His experience seemed to go beyond the typical overview effect astronauts describe, implying the Moon may hold deeper meaning or secrets. His reflections evoke a mystical quality to the lunar surface, defying simple scientific explanation. Aldrin's comments also raise broader questions about humanity's place in the universe. For millennia, the Moon has inspired mythologies, religious beliefs, and scientific inquiry. Aldrin suggests that the Moon's significance might extend beyond its role as Earth's satellite, hinting at mysteries yet to be understood, potentially reshaping our understanding of the cosmos and our role in it. This resonates with the idea that the Moon symbolizes the unknown, a reminder of the mysteries still beyond human comprehension. One intriguing aspect of Aldrin's perspective on the Moon is what might lie beneath its surface. While the Apollo missions, including Apollo 11, provided valuable data, much of the Moon's interior remains a mystery. Some scientists believe the Moon could reveal clues about the solar system's formation, and Aldrin's musings suggest it may hold more than geological secrets, perhaps hidden structures, ancient artifacts, or other unknown phenomena. Aldrin has also fueled speculation about extraterrestrial activity. He once mentioned seeing an unusual object during the Apollo 11 mission, later clarifying it was likely part of the rocket, but the incident added to the mission's mystique. The Moon's unique position in Earth's orbit, being unusually large and nearly perfectly circular, has led some to theorize it might be an artificial object created by an advanced civilization. While Aldrin hasn't endorsed this idea, his open-mindedness toward the Moon's mysteries leaves room for speculation. Aldrin sees the moon as a crucial stepping stone for future space exploration. He has long advocated for continued lunar exploration and using the moon as a base for missions to Mars and beyond. Aldrin believes humanity's future lies in space, and establishing a permanent presence on the moon is essential, not just for scientific reasons, but also as preparation for further space travel. To him, the moon is both a mystery to solve and a gateway to the broader cosmos. Aldrin's respect for the unknown drives his curiosity about the moon, believing much remains undiscovered. He encourages humanity to keep exploring and questioning what we know, aligning with the spirit of pushing the boundaries of space exploration. For him, the moon is the frontier where humanity might confront the unknown and uncover extraordinary discoveries. Recently, Aldrin has stressed the need for renewed space exploration, especially as Earth faces global challenges. He believes the moon could help address these issues by serving as a platform for scientific research, resource extraction, and even habitation. His reflections on the moon's mysteries suggest that some of the answers to pressing human challenges may lie not on Earth, but on the moon and beyond. The implications of Aldrin's views on the moon are profound. If the moon is more than just a barren rock, as Aldrin implies, it could reshape our understanding of the universe and our place in it. The possibility that the moon holds hidden secrets, whether ancient artifacts, unknown geological formations, or signs of extraterrestrial activity, challenges the conventional narrative of space exploration and raises questions about what we truly know about our closest celestial neighbor. Aldrin's reflections encourage a re-evaluation of humanity's relationship with space. While space exploration has traditionally been driven by scientific curiosity, technology, and geopolitical competition, Aldrin suggests deeper philosophical reasons to continue exploring. The moon, in his view, symbolizes the unknown and reminds us that mysteries in the universe remain to be uncovered. This perspective calls for a more holistic approach to space exploration, considering not just the scientific and technological aspects, but also the broader implications for humanity's future. As NASA's Artemis program aims to establish a sustainable presence on the moon, Aldrin's reflections gain more significance. This new era of lunar exploration could provide answers to some of Aldrin's questions and reveal new mysteries. The possibility that the moon holds more than we previously thought adds excitement and intrigue to upcoming missions. It also reminds us that despite technological advancements in space exploration, profound questions about the universe remain unanswered. Aldrin's fascination with the moon stems from his first-hand experience of walking on its surface, which significantly shaped his worldview and led him to question established understandings of our natural satellite. While most focus on the triumph of Apollo 11, Aldrin's reflections emphasize the strangeness and mystery of the experience. His perspective suggests the moon may hold more significance than we realize, challenging our knowledge and inviting deeper exploration. Aldrin's insights indicate the moon may not be just a barren, lifeless rock, but something much more enigmatic. Aldrin's comments often suggest that the moon could be a key to understanding deeper cosmic mysteries, possibly linked to our understanding of space, time, and the origins of life. One major question raised by Aldrin's reflections is the moon's origin. While the prevailing theory is that the moon formed from debris after a giant impact between Earth and another planetary body, some aspects of its composition and behavior remain unexplained. For example, certain elements on the moon's surface do not fit neatly into this hypothesis, leading Aldrin to speculate that unknown processes may have influenced its formation. Aldrin has also expressed intrigue over the moon's gravitational relationship with Earth. While its role in stabilizing Earth's axial tilt in controlling tides is well known, Aldrin has suggested that this relationship might be more complex than we currently understand. The moon's orbit and its influence on Earth raise questions about whether an unknown force may govern these interactions, inviting further exploration of how celestial bodies affect one another in ways that might still be unexplored. Aldrin's interest in the moon is strongly connected to his curiosity about extraterrestrial life. While he has never claimed to have seen aliens or found direct evidence of their existence, his open-mindedness about space's mysteries often leads to speculation. The moon, being Earth's closest celestial body, is seen as a potential starting point for discovering life beyond our planet. Aldrin has suggested that if extraterrestrial life exists, it might have left traces on the moon, such as artifacts or subtle signs not easily detected. This makes the moon a significant target for future exploration. Aldrin's reflections also show his willingness to consider unconventional ideas, including the possibility that advanced civilizations visited the moon long before humans. Though speculative and lacking evidence, his open-mindedness encourages exploration of these ideas to deepen our understanding of the moon's history. Aldrin has speculated that the moon could serve as a hub for future human expansion into space. He has long advocated for permanent lunar bases to support missions to Mars and beyond, making the moon a critical stepping stone for humanity's future in space. His reflections weave together two ideas. The moon holds unexplored mysteries, and it plays a vital role in humanity's continued exploration of the cosmos. Aldrin's Apollo 11 experience instilled in him a sense of wonder and humility, seeing the moon as a symbol of the unknown, urging humanity to push the boundaries of knowledge and capabilities. A recurring theme in Aldrin's reflections is the potential for life beyond Earth. While the moon is unlikely to harbor life, its proximity to Earth and role in space exploration make it a key location for studying conditions that could support life elsewhere. Aldrin has suggested that the moon could be a laboratory for experiments to help understand the origins of life on Earth and other planets. Studying the moon's geology and solar interactions could offer clues about life's emergence in the universe. Aldrin is also interested in the moon as a platform for studying Earth and the cosmos. Its lack of atmosphere and stable position make it ideal for astronomical observations. He has advocated for building lunar observatories to study the universe in ways not possible from Earth, highlighting the moon's potential to unlock the mysteries of the universe. The idea of the moon serving as a base for human activity raises important questions about resource utilization. Aldrin has often discussed the potential for mining the moon's resources, particularly helium-3, a rare isotope that could be used for future energy production. Although this presents significant technical and ethical challenges, the possibility of supporting human exploration and development in space has intrigued Aldrin for decades. He emphasizes the need for careful planning and international cooperation to use these resources responsibly and sustainably. Aldrin is also optimistic about humanity's future in space. He believes that while space exploration poses challenges, they are not insurmountable. His Apollo 11 experience instilled in him confidence in human ingenuity and perseverance. For Aldrin, the moon is both a challenge and an opportunity, a place where humanity can test its limits and move forward into new frontiers. His reflections often emphasize that the moon, while mysterious and sometimes daunting, symbolizes hope and humanity's potential for great achievements. Beyond its scientific and exploratory significance, Aldrin has suggested the moon could help foster global unity. The Apollo 11 mission was a triumph for all humanity, not just the United States. Aldrin frequently speaks of the awe and wonder people worldwide experience watching humans set foot on another world. He believes future lunar missions could unite nations in pursuit of common goals, making the moon not just a scientific frontier, but a place where humanity collaborates toward a shared future. Aldrin's reflections emphasize the importance of preserving the moon's environment. Though a strong advocate for human exploration and development, he stresses the need for careful stewardship of the moon's fragile ecosystem. Its barren surface holds vital clues about the solar system's history, and Aldrin warns against damaging or disrupting this natural environment. His views highlight the balance between exploration and preservation, a critical theme as humanity's presence in space grows. Aldrin also believes the moon could serve as a training ground for future spacefarers. Its harsh conditions, low gravity, lack of atmosphere, and extreme temperatures provide an ideal environment for astronauts to develop skills and technologies for missions to Mars and beyond. He advocates for lunar training facilities, aligning with his vision of using the moon as a stepping stone for further exploration. Additionally, Aldrin sees potential in space tourism and commercial ventures on the moon. With companies like SpaceX and Blue Origin advancing space travel, he envisions partnerships between governments and private industry, making the moon a destination for tourists as well as scientific exploration. This idea builds on the growing trend of space commercialization, where private companies are increasingly taking on roles traditionally held by government space agencies. Aldrin envisions a future where private enterprise plays a key role in making the moon accessible, creating new opportunities for economic development and human experience. Beyond tourism, Aldrin sees the moon as a platform for advancing space-based manufacturing and technology development. The moon's low gravity and lack of atmosphere offer unique conditions for testing technologies such as space habitats, energy production, and resource extraction. He has emphasized the moon's potential as a testing ground for technologies critical to future Mars missions, including advancements in life support systems, radiation shielding, and habitat construction, all of which could be refined on the moon before being used for longer missions to Mars or beyond. Aldrin's interest in technology focuses on the long-term sustainability of human activities on the moon, particularly through renewable energy sources like solar power. The moon's lack of atmosphere and extended sunlight make it ideal for generating solar energy, which could power lunar bases and support human habitation. Aldrin has suggested that lunar solar power could also meet Earth's energy needs, transmitting energy back to Earth via microwave or laser beams. This concept, though early in development, could help address global energy demands and reduce reliance on fossil fuels. He also believes the moon's resources, such as helium-3 for fusion energy, could play a crucial role in solving challenges like climate change and resource depletion. While fusion energy technology is still being developed, Aldrin sees the moon playing a key role in providing clean, sustainable energy for future generations. His reflections also emphasize the importance of international cooperation in the exploration and utilization of lunar resources, stressing that the moon belongs to all humanity. Aldrin advocates for international frameworks to ensure responsible use of space resources, similar to the treaties governing Antarctica, to prevent conflicts and ensure equitable sharing of benefits. He frequently highlights the idea of space as a global commons and views space exploration as a shared human endeavor that transcends borders and political divisions. This perspective is especially relevant as more countries and private entities join space exploration. Aldrin advocates for international cooperation, believing that the challenges of exploring and using the moon and other celestial bodies are too vast for any one nation or organization to handle alone. He envisions countries working together, sharing knowledge, resources, and expertise to benefit all of humanity. Aldrin also emphasizes long-term thinking over short-term, politically driven decisions. For him, the moon offers a chance to lay a foundation for future exploration that will benefit both current and future generations of astronauts and spacefarers. He believes today's decisions on how we explore and use the moon will significantly impact humanity's future in space. Therefore, he supports a long-term, strategic approach prioritizing sustainability, cooperation, and responsible resource use. Aldrin's focus on long-term thinking ties closely to his belief in inspiring the next generation of scientists, engineers, and explorers. Throughout his career, Aldrin has passionately advocated for STEM education, often emphasizing the need to inspire young people to pursue careers in science and space exploration. He sees the moon, with its mysteries and potential, as a unique opportunity to capture the imagination of future generations. By pushing the boundaries of our knowledge and continuing to explore the moon, Aldrin hopes to inspire young people to dream big and contribute to advancing human knowledge and exploration. Aldrin's reflections on the moon also carry a spiritual dimension, often overlooked in discussions of space exploration. Though a man of science, Aldrin has acknowledged the profound awe that comes with seeing the universe from space. He often describes walking on the moon as both a scientific and deeply spiritual experience. For Aldrin, the moon symbolizes our connection to something larger, a reminder of the vastness of the universe and our small yet significant place within it. This sense of wonder is central to his reflections, underscoring that exploring celestial bodies isn't just about data or resources, but expanding our understanding of the universe and ourselves. This spiritual aspect also informs Aldrin's views on the ethical responsibilities of space exploration. He emphasizes the need for humility and respect, recognizing that we are venturing into parts of the cosmos we don't yet fully understand. Aldrin believes that as we explore the moon and beyond, we must act as stewards of the universe, avoiding harm to the environments we encounter or exploitation of resources that could negatively impact future generations. This view reflects a deep respect for the unknown and the potential for space exploration to reshape our understanding of the universe and ourselves. Aldrin's thoughts on the moon intersect with his broader interest in human evolution and survival. He has spoken frequently about humanity's need to expand beyond Earth to ensure long-term survival. For Aldrin, the moon is the first step, a place to develop the technologies and skills needed to thrive in space. The challenges of space exploration, he believes, will push humanity to evolve, both technologically and in understanding what it means to be human. Thus, the moon is not just a destination, but a catalyst for human evolution, testing our limits and preparing us for the next phase of cosmic exploration. Aldrin's vision of the moon as a stepping stone is also tied to his interest in space colonization. He advocates for permanent human settlements on the moon as a way to ensure humanity's continued presence in space. These settlements, he believes, could serve as bases for future missions to Mars and beyond, providing the infrastructure necessary for long-duration space travel. Aldrin's vision of lunar colonization isn't just about survival, though. It's also about expanding human civilization into new frontiers. He envisions a future where humans live and work on the moon, creating societies that reflect the diversity and creativity of humanity. In addition to colonization, Aldrin believes the moon could play a key role in scientific discovery. He frequently speaks of its potential as a base for studying the cosmos, conducting experiments, and pushing the limits of human knowledge. The moon's unique environment, lacking an atmosphere and close to Earth, makes it ideal for scientific research, particularly in astronomy, geology, and biology. Aldrin envisions the moon becoming a hub for global scientific discovery, drawing researchers from around the world to unlock the universe's secrets. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us what surprises you expect from this reveal. We want to hear from you. Thanks for watching, and see you next time. Imagine waking up to a headline that reads, "NASA discovers Earth 2.0. Sounds incredible, right? A planet just like ours with oceans, breathable air, and maybe even life. Well, as exciting as that sounds, the truth is far from it. Despite the countless planets we've discovered, we haven't found a single one that we can truly call habitable. Today, we're going to cut through the hype and look at why none of the so-called Earth-like exoplanets are actually capable of sustaining life as we know it. If you're ready to separate fact from fiction, let's dive in. We will be going planet by planet to explain why each potentially habitable exoplanet is probably inhospitable, and afterward, we will go over some planets that actually have a better chance of being habitable. Let's start with the well-known Kepler-22b. Kepler-22b is in its star's habitable zone, meaning temperatures are right for liquid water. However, beyond that, it has no similarities to Earth and should have been removed from the list of potentially habitable exoplanets long ago. For one, we don't accurately know its mass. We only know it's less than 9 times the mass of Earth, but nothing more. We do know its radius, which is 2.3 times wider than Earth's. Rocky planets don't usually get that large, and with Kepler-22b's likely mass, there's really only one reasonable conclusion. Kepler-22b isn't a rocky planet. This means it probably doesn't even have a solid surface, and more closely resembles Neptune than Earth. There is a possibility that Kepler-22b could be a planet entirely covered in hundreds of miles of water, which could explain its low density. However, just because water might be present doesn't mean the planet is habitable. Oceans this deep are unlikely to be suitable environments for life. From what we know, life seems to require volcanic activity to get started, either through hydrothermal vents in the deep ocean or hot springs on land. Achieving these conditions is difficult when all the volcanoes are submerged beneath an ocean, with such high pressure that the bottom layers turn solid. This extreme pressure makes it nearly impossible for the necessary chemical interactions to occur, which are crucial for the emergence of life. So whatever Kepler-22b is, it's probably more like a smaller version of Neptune or an ocean planet with water too deep to support life. It's safe to conclude that despite having the right temperatures for life, Kepler-22b most likely doesn't have anything else that would make it habitable. This is crucial for understanding the rest of this video. Just because an exoplanet is in the habitable zone of its star doesn't mean it's actually habitable. The habitable zone only indicates that a planet within it could have the right temperatures for liquid water on its surface. It says nothing about the amount of water, its atmosphere, whether it has enough atmospheric pressure to support liquid water, its size, or any of the other key factors needed to make a planet truly habitable. From what we know so far, habitable planets are rare, extremely rare. Anyway, the next exoplanet on this list is Kepler-186f. At first glance, Kepler-186f looks a lot more promising than Kepler-22b. For one thing, it has a mass that's pretty close to Earth's, at around 1.5 times Earth's mass, which means it's most likely a solid planet with a rocky surface. Out of all the planets I'm going to discuss today, Kepler-186f is one of the few with the best potential for habitability. However, it does have a significant drawback. Its equilibrium temperature sits at around 120 degree, 85 Fahrenheit, which makes it colder than the average day on Mars. In fact, its temperature is roughly between what you'd expect on Mars and Jupiter. To be fair, we don't actually know Kepler-186f's real temperature. The estimate we have assumes it has no atmosphere. If it does have one, a greenhouse effect could warm it up. However, that doesn't change the fact that this planet would still be extremely cold, even with an Earth-like atmosphere. If you manage to give it an atmosphere thick enough to make temperatures more habitable, it would be very easy to go too far and end up with a Venus-like atmosphere. So Kepler-186f is probably either too cold to support life in a very delicate and unlikely balance, or it could be a hellish Venus-like world. It's caught between two bad extremes, and we just don't know which one is the case. There is still a small chance that Kepler-186f could be habitable, but we wouldn't get our hopes up. You might have heard that Kepler-186f could have red plants if it were habitable, and that's likely true. However, this planet highlights a bigger issue in exoplanet science. People tend to focus almost exclusively on planets that might be habitable. Whenever Kepler-186f comes up, no one ever seems to mention Kepler-186b, C, D, and E, the other 4 planets in the system. These planets, all between 1 to 2.5 Earth masses, orbit much closer to the star than Kepler-186f. They are 4 additional worlds, each with the potential to be just as interesting as places like Mars, Venus, Titan, or Mercury, yet they hardly get any attention. Planets don't need to be habitable to be fascinating, but by constantly zeroing in on possible habitable worlds like Kepler-186f, we end up overlooking the thousands of other equally intriguing planets out there, waiting to be explored. But it only gets worse from here. Compared to Kepler-186f, Proxima b is, in our opinion, the least likely to be habitable of any planet on this list. In fact, it's not just uninhabitable, but so extremely uninhabitable that Mars and Venus look like paradises in comparison, and we are not exaggerating. The idea that Proxima b could even be considered potentially habitable is baffling because so much is going wrong with it that habitability seems impossible. Of course, we won't know for sure until we learn more about its environment, but with the data we have so far, Proxima b appears as good as dead. Everything that could possibly go wrong for Proxima b has, from its star's behavior to its distance from that star and the existence of Proxima Ca, a second planet in the same system. Proxima b seems to have everything working against it. Here's a quick list of what likely makes Proxima b an irradiated wasteland that would make Mercury jealous. First, it orbits a red dwarf prone to flares. Second, these flares likely stripped away any atmosphere and oceans, assuming it ever had them. Third, red dwarfs, especially when young, often eject volatiles like water, making it unlikely that Proxima b even formed with water in the first place. 4. Proxima b is likely tidally locked to its star, meaning one side of the planet always faces the star, while the other remains in perpetual darkness. This creates extreme temperature differences between the two sides, which would make it incredibly difficult for any form of life to survive. 5. Proxima c exists, and there's some evidence suggesting an asteroid belt between the two planets. If this belt is indeed real, Proxima b would be in a prime location to have asteroids flung toward it from time to time. Over the planet's long history, these asteroid impacts may have been frequent and severe enough to completely sterilize any chance for life to develop. And 6, temperatures on Proxima b can spike drastically due to flares from its star, Proxima Centauri, which regularly bombards the planet with intense radiation. It's really bad. With all of this working against it, it's difficult to imagine that Proxima b could be habitable. Of course, we don't know exactly what the planet's environment is like since it doesn't transit its star from our viewpoint, which makes studying its atmosphere extremely challenging. And even if we could, it's likely that Proxima b doesn't even have an atmosphere. These issues aren't unique to Proxima b. They are actually common problems for most planets orbiting red dwarfs, including the next one we'll be discussing. TRAPPIST-1 is one of the most fascinating systems we've found, with 7 Earth-sized planets orbiting its star, 3 of which are in the habitable zone. However, like Proxima b, these planets are subject to flares from a red dwarf star. TRAPPIST-1 is relatively calm compared to other red dwarfs, but this is likely due to its age, which is around 8 billion years. It was probably much more active when it was younger, similar to Proxima Centauri. Over its 8 billion year history, the system has likely had enough time to strip the oceans and atmospheres from any planet that might have had them, and we have evidence supporting this. TRAPPIST-1b, the first planet in the system, is likely airless, according to data from the James Webb Space Telescope, making it comparable to a super-Mercury. This isn't shocking, but so far TRAPPIST-1c, D, and G also show signs of being airless, with insufficient data for E, F, and H. This is concerning for the entire system, as if these 4 planets lack atmospheres, it's very likely the remaining 3 do as well. TRAPPIST-1c might hold on to a thin atmosphere, but this doesn't change much. It appears most of the TRAPPIST-1 planets lack atmospheres, even the ones in the habitable zone. K2-8b is our next stop, and it's over 8 times the mass of Earth. With a mass that large, it's not Earth-like at all. To put it in perspective, it's about half the mass of Neptune, which it's likely either an ice giant or an ocean world, similar to Kepler-22b. However, K2-8b stands out because the James Webb Space Telescope has potentially discovered dimethyl sulfide, a possible sign of life. But this has been heavily exaggerated, so let us clear things up. James Webb did not directly detect dimethyl sulfide, only evidence suggesting its presence, and even that is not confirmed. The scientists involved never claimed they had definitively found dimethyl sulfide, only possible indications. So any claims that life has been discovered are pure clickbait. In addition, James Webb detected potential signs of a water ocean on K2-18b, but just like the dimethyl sulfide, this isn't confirmed either. In fact, recent findings suggest that lava oceans, not water, are a more likely explanation for the data. So while the initial excitement centered around the possibility of water, the reality is pointing towards something far more extreme. To sum it up, K2-18b is probably an uninhabitable super-Venus with endless lava oceans covering its surface. Even though it's almost certainly not capable of supporting life, like all the other planets we've discussed, a super-Venus with lava oceans still offers a fascinating subject for further scientific study. Gliese 617cc, similar to Kepler-186f, does have a potential chance of being habitable. Its estimated temperature is around 30 nanodegraph, assuming it lacks an atmosphere, which makes it somewhat better than Kepler-186f. However, Gliese 6667cc's mass is significantly higher, at over 3.5 times that of Earth at minimum, and it orbits another red dwarf. Because of its large mass, it's more likely to retain an atmosphere compared to smaller red dwarf planets. But this could also be a downside, as too much atmosphere could result in Gliese 6667cc becoming another super-Venus, much like K2-18b. Like Kepler-186f, a very delicate balance is required to achieve a habitable temperature on this planet, which is not particularly probable. Still, unlikely doesn't mean impossible, so out of all the planets on this list, we believe Kepler, 186 and Glea 606 cc have the best chance of being habitable. There are many other exoplanets that could potentially be habitable, but most of them remain uncertain due to the lack of sufficient data. Garden B is a prime example. We know so little about this planet that we decided to leave it out of this video entirely. Even after months of researching and analyzing various potentially habitable exoplanets, the conclusion remains the same. Only one planet candidate out of many truly stands out as having a good chance of being habitable. That planet is TOI 700d. We need to mention that TOI 700d orbits a red dwarf, which might seem hypocritical since we eliminated Proxima b and the TRAPPIST-1 system for the same reason. However, the difference here is that TOI 700d's star is a young red dwarf, and this youth brings several advantages to D's potential habitability. First, the star is much brighter than typical red dwarfs of its size because of its young age. This brightness means TOI 700d orbits farther from its star than other red dwarf planets in the habitable zone, reducing the likelihood of atmosphere loss or tidal locking. D also gets nearly the same amount of energy from its star that Earth receives from the Sun. While we thought TRAPPIST-1c would be Venus-like for similar reasons, that turned out to be wrong, but D still receives a very Earth-like amount of energy. TOI 700d is about 70% more massive than Earth, which makes it likely rocky, but also large enough to retain an atmosphere more easily. Its size and youth also suggest it is probably geologically active, helping it to build and maintain an atmosphere. Additionally, TOI 700d has a companion planet, TOI 700c, in the same system. C is around 7 Earth masses, which means it likely formed closer to the star and would have absorbed much of the inner system's material. This indicates that TOI 700d must have formed farther out, where planets can accumulate more volatiles like water. As a result, if TOI 700d formed farther from the star, it would have had more resources to develop an atmosphere and oceans. TOI 700d has a lot going for it. There are still thousands of different environments this planet could have, but out of all the potentially habitable exoplanets I've researched, this is the only one that we could genuinely see as being an Earth-like world with oceans and an atmosphere. However, this video serves as a reminder that just because a planet is in the habitable zone, it doesn't mean it's actually habitable. Most of these planets are likely as inhospitable as Mercury, Venus, or Mars, if not worse. Habitability is highly improbable. Is it possible? Yes, absolutely, but we haven't found any solid candidates yet. So whenever you see an article claiming Earth 2.0 has been discovered, check for 3 critical details: the planet's size, temperature, and the type of star it orbits. These are the main factors that determine whether a planet can support life. There are habitable planets out there, and one day we will discover a truly Earth-like world. We firmly believe that, but we just haven't found one yet. We've explored thousands of planets, examined endless data, and while we found some interesting possibilities, none of them meet the criteria for habitability. Thank you for watching another episode of A World to Discover, and if you enjoyed this video, make sure to check out our other videos covering exoplanets and the many fascinating space discoveries we've uncovered so far.
Professor Albert Einstein, who helped discover the atom bomb.
What do you put the chances of having found life?
So we have the observations, they're beaming in right now. So we're waiting for the data to come to us, and the analysis will start anytime.
Scientists have reached a significant milestone in the search for an interstellar home. In a surprising discovery made by the James Webb Space Telescope, they found a new planet with properties strikingly similar to Earth. Experts are now speculating that this planet could be the ideal home away from home and may already host extraterrestrial life. However, in the midst of this excitement, researchers in the scientific community stumbled upon yet another planet that could be even more suitable for humans than Earth. What are these newly discovered planets, and where were they found? What attributes lead experts to believe these planets are suitable for human life? What are the chances of finding intelligent extraterrestrial life on them? Stay tuned as NASA has just uncovered a new planet better for life than Earth. With the growing threats of global warming, climate change, pandemics, and natural disasters, scientists believe Earth is slowly approaching a point of no return. It's only a matter of time before a catastrophic event could wipe out humanity. In light of this, researchers have been searching for a new planet in the cosmos that could serve as our next home, much like Earth. Initially, the search focused on planets within our solar system that could potentially support human life. This led the scientific community to send probes to various planets throughout the mid and late 1900s. Because Jupiter and Venus were too close to the Sun, the best options were narrowed down to Mars, Jupiter, Saturn, and Uranus. However, it became clear later that none of these planets would be suitable for human life. Jupiter's weather is extremely unstable, making it the most unpredictable planet in our solar system. Saturn's atmosphere is rich in hydrogen and experiences helium rain, while Uranus lacks oxygen, making it impossible for humans to breathe there. The most promising candidate so far is Mars. Although Mars is dry, arid, and prone to dust storms and radiation, experts like Elon Musk remain optimistic about making it habitable. Plans to establish a base on Mars are already in progress, but creating such a base would be challenging. It would require replicating Earth's conditions, including oxygen, gravity, water, temperature, and air pressure. The cost of such an endeavor would be astronomical, amounting to billions or trillions of dollars. It would be far easier to find a planet with the right conditions elsewhere in the universe rather than transforming Mars into a habitable one. As a result, scientists have expanded their search beyond our solar system, exploring distant regions of space to identify a planet like Earth, or perhaps an even better one. To streamline the search for a suitable replacement, scientists developed the Earth Similarity Index. This index evaluates planets using factors like temperature and atmospheric pressure to determine how closely they resemble Earth and whether they could support life. The scale runs from 0.0 to 1, with higher numbers indicating a closer match to Earth. For instance, a planet with a similarity index of 0.9 would be nearly identical to our planet. With significant technological advancements, scientists have been able to explore the deepest regions of the cosmos, revealing promising candidates for human habitable planets. Among these are exoplanets and moons with striking similarities to Earth. One notable discovery from 2019 is the planet Teegarden B, one of the closest potentially habitable planets, situated about 12.4 light-years away. Its mass is 1.05 times that of Earth, making it almost identical in size. Teegarden B orbits an M-type star, Teegarden, a red dwarf. These stars are relatively cool, with surface temperatures below 3,600 Kelvin. The Teegarden star in particular is much smaller than our Sun, with a temperature around 2,700 Kelvin. Despite its low heat, the red dwarf provides enough warmth for its planets, Teegarden B and Teegarden C. Teegarden B orbits its star at a distance of 0.252 astronomical units, while Teegarden C, the other planet in the system, orbits at 0.04 astronomical units, completing its orbit in about 11 days. Both planets share characteristics with Earth, notably being located in the habitable zone of their star. This zone refers to the distance at which liquid water could exist on the planet's surface. If too far, the water freezes, too close, and it evaporates. For example, Neptune has frozen water due to its distance from the Sun, while Venus lacks water altogether, even in its atmosphere. Earth, however, is at the perfect distance for life. The discovery of Teegarden B and C indicates Earth isn't unique in this regard. Teegarden B stands out with a promising score of 0.95 on the Earth Similarity Index, ESI, which means it's nearly 100% similar to Earth. However, uncertainties remain regarding air pressure and temperature, with estimates ranging from 0 to 50 G. If its atmosphere is Earth-like, its surface temperature could be around 2080. Teegarden C, being farther from the star, is more likely to be too cold. Experts believe it has only a 3% chance of a warm surface temperature and suspect its atmosphere may resemble Mars, with temperatures near 47 degrees Celsius. Its ESI score is 0.68. Currently, researchers don't know much about the atmospheres of Teegarden B and C, as both are tidally locked to their star. Scientists estimate their atmospheres could be 13 to 17 times denser than Earth's. There's plenty of speculation about these two planets, with some believing they could be future homes for humanity if Earth faces a catastrophic event. On the other hand, many scientists are also exploring the possibility of extraterrestrial life on these planets. For centuries, we've questioned whether we are alone in the universe. This mystery has driven both astronomy and cosmology. Despite extensive research, no alien civilizations have been found. No stars or planets have yet exhibited the ideal conditions to support extraterrestrial life. The planets that are thought to be viable for life are those with the right temperatures, atmospheres, and those situated in the habitable zones of their stars where water can exist. Water is essential for any living organism. As the saying goes, water is life. Scientists have long recognized that wherever water is present in the universe, life can likely be found. This is why planets such as T-Garden b attract significant attention when researchers search for planets that might harbor alien life. But T-Garden b isn't the only planet of interest. Other planets are also considered strong candidates for supporting extraterrestrial life. One planetary system in particular is seen as even more promising than T-Garden, the TOI 700 system. Located in the constellation Dorado, this star system contains 4 planets, with 2 of them residing in the star's habitable zone. The standout planets are TOI 700d and TOI 700e. Both planets have masses comparable to Earth's and feature rocky surfaces. TOI 700e is approximately 95% of Earth's size, with an orbital period of 28 days, while TOI 700d is about 105% the size of Earth, completing its orbit in 37 days. What makes the TOI 700 system particularly intriguing is its age, around 1.5 billion years. That puts it just a few billion years younger than our solar system, which is about 4.6 billion years old. According to cosmic timelines, 1.5 billion years is more than enough time for life to develop and evolve on a planet. Some experts believe that TOI 700e and 700d could host rich biospheres. If these planets have atmospheres warmer than Earth's, they could not only be suitable for us but also for alien species with similar biological traits. If we were to find life on these planets, it would likely resemble the life forms found on Earth, as we tend to look for biological traits that are familiar to us. However, this is all speculative at this stage. Until we can closely study these planets' atmospheres, surfaces, and environmental conditions, we may never truly know what kinds of life forms they might host, if any at all. It's possible that planets scattered across the cosmos could house similar life forms, shaped by the same fundamental principles of biology. But there is still so much about the vast universe that remains beyond our comprehension. The potential for completely different evolutionary paths driven by conditions that are unlike anything we've encountered adds an even greater layer of mystery. For instance, the principles of evolution could function very differently on other planets compared to Earth. Evolution, like gravity, is thought to be a universal process. The concept of evolutionary convergence suggests that unrelated species can develop similar traits when they face comparable environmental challenges. Consider species like crocodiles, which have evolved to swim and breathe underwater. If similar creatures existed on water-dominated planets, they too would evolve to adapt to underwater environments. However, their evolutionary paths might differ. While some aquatic animals have developed gills to extract oxygen from water, others have not, relying on different adaptations for survival. Similarly, birds, insects, mammals, and other airborne creatures have evolved various methods to take to the skies, each suited to their specific needs. Birds, for example, soar by flapping their wings, generating the lift they need to remain airborne, while mammals like flying squirrels use a different approach, gliding gracefully by stretching out their loose skin to create a makeshift parachute. Every creature has its own unique way of conquering the air, whether it's through flapping, gliding, or hovering. It's highly likely that this incredible diversity of flight and movement is also unfolding on other planets with biolife, scattered throughout the universe, where alien species have evolved their own specialized adaptations to navigate their environments. There is also a possibility that some of these planets could evolve complex biolife forms. These advanced life forms would be entirely different from anything we've encountered on Earth. Environmental conditions like temperature, atmospheric pressure, and water availability could heavily influence how these organisms evolve, driving them to adapt in ways that seem strange to us. Scientists are keeping their minds open to the idea of discovering biolife that defies our current understanding. On Earth, some organisms exhibit bizarre traits and have adapted to survive in extreme environments. from the deepest parts of the ocean to the hottest volcanic vents. These extraordinary life forms, known as extremophiles, can thrive in conditions that would be lethal to most other species, such as extreme temperatures, high radiation, or toxic chemicals. Their unique adaptations make them valuable models for the kinds of alien organisms that might exist on other distant planets with similarly harsh or unusual conditions. So far, most searches for extraterrestrial life have centered around planets with close similarities to Earth, focusing on finding life as we know it. However, studying extremophiles helps us imagine how life could evolve in radically different environments, expanding our understanding of where life might exist in the cosmos. But what if we change our perspective? Instead of limiting our search to life as we know it, we could widen the scope and explore the possibility of life that's fundamentally different. Life as we don't know it. After all, given how little we truly understand about the vast complexities of the universe, it's not unreasonable to consider that extreme bio-life forms could be thriving on planets we've dismissed as uninhabitable. These planets may endure intense radiation, have an excess of particular elements, experience extreme temperatures far beyond what we consider survivable, or face severe, relentless weather. Yet in these harsh and hostile environments, there may exist life forms perfectly adapted to not just survive, but to flourish in conditions that would be unthinkable for organisms like those found on Earth. A few years ago, astronomers identified a new type of planets known as hen exoplanets, which may have the potential to support life. These planets are significantly larger, hotter, and covered with oceans, providing them with a wider habitable zone compared to Earth. Some of these exoplanets experience atmospheric pressures as high as 200 XU. They meet important criteria, including having substantial amounts of water. However, due to the extreme conditions, any biolife that might exist on these planets would be very different from the life forms we are familiar with. One fascinating example from this category is planet K2-18b. Discovered in 2015, it is one of the numerous planets found by NASA's Kepler Space Telescope. The Kepler Space Telescope, launched by NASA in 2009, was designed to search for Earth-sized planets orbiting stars within nearby regions of the cosmos. Named after the astronomer Johannes Kepler, the telescope was placed in a heliocentric orbit, meaning it orbits the Sun while gradually drifting farther away from Earth as it continues scanning the universe. Thanks to Kepler, scientists determined that approximately 25 to 50% of stars visible in the night sky likely have small rocky planets, much like Earth. Kepler's findings included multiple planets located within the habitable zones of their parent stars, and K2-18b is one such planet. Situated roughly 124 light-years from Earth in the constellation Leo, this planet is reminiscent of a mini Neptune orbiting a dim red dwarf star. Researchers suggest that planets like K2-18b could harbor life due to their potential to contain biomarker molecules. These molecules, often remnants of organic processes, can be detected in soil and water samples by space rovers or in the atmosphere through telescopes and orbiters. Common biomarker molecules include methyl chloride and dimethyl sulfite. In some cases, planets may have elements such as oxygen, methane, or hydrogen as predominant components. Earth's life forms are carbon-based, as carbon is the dominant element on our planet. If a planet lacks carbon, life forms there could have a radically different structure. For example, life forms based on hydrogen would be unrecognizable to us, especially when viewed through the lens of our own biochemistry. Planets like K2-18b are rare because they share the same key biomarker as Earth, carbon. The James Webb Space Telescope, or JWST, has revealed the presence of carbon molecules alongside traces of methane and carbon dioxide on this planet. This discovery positions K2-18b at the forefront of Earth-like planets with the potential to support biolife. Kepler K2-188b isn't the only noteworthy planet. Another intriguing but debated candidate is TRAPPIST-1b, discovered in 2016. This planet is about 1.5 times larger than Earth, and data indicates it may be capable of supporting life. According to NASA astrophysicist Thomas Green, TRAPPIST-1b has a thick atmosphere that helps protect its surface from excessive heat or radiation. However, the planet orbits much closer to its star than Earth does to the Sun, receiving far more light. The JWST has found that TRAPPIST-1b's daytime temperatures exceed 200 degrees, making it lethal for humans, yet possibly ideal for other types of life forms. With advanced space telescopes like the James Webb, we can now explore the atmospheres of distant planets in greater detail than ever before. Thanks to the recent incredible discoveries by the JWST, it seems clear that many more astonishing findings are on the horizon. In fact, some scientists believe that there could be planets in the universe with even more favorable conditions for life than Earth. These planets are known as superhabitable worlds. Imagine a planet that is larger, safer, and more hospitable than Earth, free from the challenges we currently face. Though still a theoretical concept, superhabitable worlds would likely be older, bigger, warmer, and perhaps even more humid than Earth. Many researchers speculate that these planets might orbit stars much older than our Sun, with significantly longer lifespans. For example, while our Sun has an expected lifespan of about 10 billion years, it took nearly 4 billion years for life to develop on Earth. Some stars, however, can last much longer than 10 billion years, allowing for a more prolonged and intricate evolutionary process on their orbiting planets. But how can we locate these ideal planets? According to many experts, the best approach is to search for planets orbiting orange stars that are cooler and less bright than our Sun. Such stars would need lifespans between 20 and 70 billion years. It is believed that life on planets around these stars could evolve fully, reaching a point where the planet's geological features and life forms are at their most developed. These superhabitable worlds would likely offer many advantages over Earth, such as more landmass, heat sources that last longer, better protection from radiation, and ideal gravitational conditions. For a planet to be truly superhabitable, it should also have an average surface temperature about 500 degrees Celsius warmer or cooler than Earth's, promoting greater biodiversity. Although no such planet has been found yet, scientists remain optimistic. The scientific community at least has a clearer idea of what they are looking for and where to search. Still, there are skeptics who argue that no planet could be better suited for human life than Earth. If such a planet existed, they claim, it would have already been discovered. However, it's important to note that the technology we have now wasn't available in the past, which might explain why we haven't found one yet. Perhaps with future advancements, our telescopes will one day reveal the perfect planet for humanity. For now, the search for a new home continues. Thanks for watching this episode. Be sure to click the video on your screen for more fascinating insights into space.